Good afternoon, ma'am. Saujanya, ma'am.
మేడం గుడ్ ఆఫ్టర్నూన్.
Madam, na voice clear unda?
క్లియర్ గానే ఉంది మేడం.
Okay, ma'am. Thank you.
ఓకే.
Good afternoon, everyone.
Good afternoon, ma'am.
Sir, can you tell me, is my voice is clear, sir?
Yes, ma'am.
Thank you, sir.
Hello.
Sir, your voice is clear. Wait for 5 minutes.
Yeah. Okay.
Shada madam, are you there?
Yes, sir. Yes, sir.
You can start, madam.
Yes, sir. Good afternoon, everyone. Uh, Good afternoon to everyone present here. First of all, thank you for giving me the opportunity to introduce myself. My name is Sharada. I'm from CSM department. On behalf of Agri College of Engineering, I extend a very warm welcome to all to this online FDP on quantum cryptography and its impact on cybersecurity in the digital age. I also extend a warm welcome to our respected resource persons, faculty members, and enthusiastic participants who have joined us from various institutions across the stage. Now, I would like to give an introduction about our resource person, B. Sairam sir. Mr. B. Sairam sir is an experienced IoT engineer with over 15 years in the industry, currently working at SVS Softwares, Hyderabad. He has expertise in sensors, integration, embedded systems, and cloud-based IoT solutions, contributing to innovative projects in smart automation and industrial IoT. Passionate about emerging technologies, he continues to drive digital transformation through practical and scalable IoT applications. Now he's going to explain about future trends and capstone project emerging trends in quantum cryptography and cybersecurity capstone project applying quantum safe security concepts. So with a great respect, I hand over the session to our resource person, Mr. B. Sairam sir, to proceed with today's talk. Welcome, sir.
Good afternoon, everybody.
Good afternoon, sir.
Thank you. Thank you for having this session and providing this opportunity. And it's very great pleasure to contribute my knowledge to you and share my knowledge and experience with you. As you know, myself is Sai Ram. I'm working in SB software solutions. So have experience in IoT and embedded domain since 7 years, as Madam introduced me. Today topic is quantum technology, quantum security. Okay. So let me have some data. Let me share some data to you. Okay. And previously, are going through the quantum technology related concepts. Okay. So I will share the one presentation on screen. Just follow me our session. Is there anybody else to join it? Shall I start the session?
Sir, you can start it.
Oh, thank you. Can you see my screen, everybody?
Yes, sir.
Yes, sir.
Can you see the presentation? Hello?
Yes, sir. Yes, sir.
Yes. Okay, fine. Okay, today our topic is quantum safe and security. Okay, so before going to the topic, I would like to tell something about quantum technology. What is the use of quantum technology at present generation? So, what is the difference between the existing technology and when you are entering? Is a new era, it's a new generation. The future upcoming generation is a new technology. So, what is the difference between traditional technologies and that is whatever the existing, whatever right now you are using technologies in computer system, computers, and quite different from quantum computers. Okay, so what makes the difference and why they are useful? What is the useful? I would like to make it a short description. Okay, so it's a technology like next generation technology which makes very strength and powerful. Why I'm saying very powerful means uh, whatever technology right now we are using, it is far faster than even our existing computers are more faster than the humans. Okay, our technology is whatever right now our technology is a 5G or 6G, whatever in internet we are using, and whatever the computers we are using for GPU or CPU, no, CPUs, these are performing the task in a fraction of seconds, okay, than the humans. Okay. Similarly, these computers are very fast. Whatever you are doing right now is very faster than humans. And the same time, same like these computers in quantum computers, quantum technology, all the tasks, all the performance, whatever doing the current computers is more faster than a existing, that is current existing technology. Okay, so in our digital system, so now we are using digital electronic digital systems. That means we use every computer uses like 0 and 1 as a bit. Okay, 0 and 1 as a bit. But whereas in quantum technology, it exists a particle which can act as a 0 and it act as a 1 at a time. Okay, that is the difference make the mm, make existing computers and quantum computers. Okay, so but the issue is making the technology is not a matter. The issue is and providing the security to the information. Okay, to this in current generation, information is the most requirement because in artificial intelligence you are training the system. This is nothing but the training of a system or nothing but a it's a way of giving the information to the computer. Okay, like AI computers, we have different methods like ML, machine learning, and deep learning ways. Okay, what we are giving to the system is the information we are giving, the structural information. Okay, when the system is learned, okay, because when the system is learned certain extent, we'll call it as a machine learning. When a system is trained, it's a depth level, it's a deep learning. So what is we are giving information, but we are storing the information in a computer, we are storing the information in servers, we are storing the information in the clouds. Okay, is there any security? For example, I am saying like I have my bank account. Okay, I have my all the information, whatever the amount, whatever the transactions made in with me is stored all in the server, in a bank server. So how far is secure? Okay, now we are seeing nowadays you are seeing uh, most of the bank threats, bank fault for fraud detections. Okay, like with the calls and messages and is encrypted data like images, they are hackers are taking the information secretly without knowing the person, without interacting with the person. They are collecting the information like say CVV or bank details and ATM numbers, credit card numbers and debit card numbers, everything. So there is no proper security. These even though we are avoiding this system with many methods, but there is no proper security. Okay, so if you are coming entering to the quantum technology, the same issue will be existed. Okay, so if to overcome that issue, if the quantum computers are more faster, if they provide the information a fraction of second, all the information to the third person, there is no security. Okay, so there are certain algorithms, certain methods to avoid that To avoid that, sharing the data of personal or professional data, category data to the third person only. Quantum technology make very different. Okay. These securities require some algorithms. Okay. So, for example, now we are using cyber security technologies to help not to hack the system. There's in basically every company and every industry, there is some hackers, professional hackers, to avoid whoever the person is uh, entering to the cyber crime. They will easily crack the data and misuse the data. So to avoid that, we are using cyber security. And in ML, in machine learning also, in IoT systems also, there is the issue with security. That security in the sense information. So, for example, myself, I am having all some IoT devices in our homes, in our houses. There are advanced devices like smart TVs, smart fridges, smart ACs, and smartphones, laptops, everything. All those are connected to the Wi-Fi. Okay, so this Wi-Fi can be easily hacked if the person can be hacked. All those devices are connected to the single systems like Wi-Fi. Since Wi-Fi can be easily hacked, all the devices IP address can be known. Okay, and they can easily crack the mobile phone, and they can easily take my data also. Okay, so in present quantum computers, it is a new generation technology which is strength with powerful and with quantum physics, and we can make the things which are impossible in today's life that in upcoming technology is that can be possible. Okay, so we are encrypting the data. Encrypting means we are hiding the data. Okay, there are different methods, cryptographic methods. There are different cryptographic methods. Okay, so our agenda is uh, post post quantum reality. So post quantum is before entering the quantum technology, we need to make some we need to make some we need precautions. Okay, we need to make some precautions, that is to hide it or to make the data secure, because the quantum computers are much faster. Okay, they can easily share the information to anybody. Okay, this make very complications in future. So to avoid that, we are making some precautions, that is and before entering to the quantum. So recently only quantum technology is introduced. Okay, that means coming to the uh, real world. Okay, so because it is very difficult to make a quantum computer, to design a quantum computer is very this environment is not suitable. Okay, this environment, they need to maintain some a standard environment to make these computers are very sensitive. This technology is very sensitive. So to avoid any misuse of this, they need some algorithms and to make the data secure. Okay, and also the main theme is quantum safe security. So the quantum safe security, the protection is a protection of digital data and communication uses new cryptographic methods. Okay, we will use new cryptographic methods and cannot break the future quantum computers. Okay, it should not. Even our computers are facing same issue. Even the next upcoming generation technology has the same issue. Then what is the use of making the new technology? So for that purpose only, we are introducing the new algorithms, new methods, and new cryptographic concepts for protecting the information. So this means that today's session, that is safety and security. Okay, safety and security. Wherever the aspects you take, wherever in real time, everywhere it requires safety and security. So safety and security not only for the humans, for all the computers. Okay, safety and security not only for the humans but also computers. Computers will have the data. Humans have the life. Okay, that's the difference. Only they are not the living beings, but they need some security. Okay, and safety also. If the data is misused, if, for example, in banking sectors, if the data is lost, then all the hackers will loot their money and jump, right? So even now we are facing same issue in quantum technology also. make the same issue, then it doesn't make any difference. So quantum is having highly protected, highly secured. Okay, when compared to the traditional systems. Okay. And why it is needed? Okay. So now today we are having like algorithms like RSA and ECC. Okay, this can be easily cracked by the quantum computers. Okay, this computers, this technology is also easily cracked by the quantum computers. So if the if the computers are cracked, then the sensitive data will be loses. Okay, then it can be stolen or misused. Okay, it may be whatever sector, like banking, healthcare, defense, personal info, whatever it may be, it can be misused. Okay, so hackers can also store the encrypted data now and distribute it later once the quantum power is available. Okay, so to avoid that, we are using post quantum reality. Okay, post quantum reality. And the other agenda is quantum resistant algorithm. So these are different types of algorithm. We are making it hybrid. Hybrid is nothing but combination of two more methods. Okay, combination of two more methods. We are making hybrid. Okay, and making a proper route map. So we have to, for any destination, there is any technology, there is a step-by-step procedure. Okay? Step-by-step procedure to approach that technology or a destination. Okay, we are making some proper route map, standardization and implementation. Any complications, we have to overcome all those things. Okay, so any system, so there is nothing is 100% accuracy. There is some issues in every system. So we have to overcome one by one. So we have to make a proper route map for it. Okay, proper route map. So whatever the things we are using, now, RSS and ESS, they can easily do the algorithms in hours. But in quantum technology, in a fraction of second, there is within no time, because in quantum, a element, as a material can be act as a positive material, positive, and at a time as a negative. That means it can act as a zero, either zero or a one. So we can easily describe. I can easily describe when you fly a coin. Okay, when you fly a coin, when it is in a toss, we can't assume that whether it is a heads or tails. Okay, similarly, a quantum bit can be a either positive or negative. We can't assume. It can act as a both. That is the specialty of quantum. Okay. So in traditional computers, 0 is a different bit and 1 is a different bit. But in quantum, it can be act as a same bit can be act as a 0 and a same bit can act as a 1. That is the difference. So this makes the things very faster. Okay. These things very faster. And the quantum threats, there are some security issues are there. So these are called threat landscapes. Okay, these threats can be overcome by different algorithms. Okay, different algorithms we can use to overcome these technologies. So now quantum computing timeline. So now we are at the stage of implementation, at a starting stage. So quantum computers are not introduced yet. They are in a stage of implementation. Okay, there is the basic level in 2015. Sorry, 2025 in a basic level. Nearly quantum computers will be hardly 100 to 1000 cubics. Okay, is in short level. So in future, in 2026 to and upcoming 2030, it will be more high, and you can overcome the error corrected. So while you are implementing, there are different makes, some limitations. Okay, we will overcome all the limitations step by step. Okay, we will overcome all the limitations step by step, and we'll make the single perfect system. Okay, in as we go 20 years back or 30 years back, our computers once upon a time, our computers are in a big group. They are maintained with a thousands of millions of wires are connected. But our laptops are very minimized, very integrated devices. Very integrated devices are added. It is very faster than existing. Okay, previously which we are using 30 years back computer and today's computer is quite different. Okay, in all aspects, like in size and appearance and its performance and its storage, everything. Similarly, in quantum computers also, we may be going to face some issues. So we'll overcome one by one, in upcoming generations or upcoming years. Okay, it's a 2025. Hardly in 10 years, we may going to overcome perfect quantum computer, quantum technology. Okay. So there are cryptographic methods. So cryptography is nothing but post-quantum cryptography is a kind of algorithm. So algorithm, as you know, algorithm is nothing but a step-by-step procedure to approach one method. Okay, the algorithm is nothing but a step-by-step procedure to approach one method. Cryptography means a concept of hiding the information. Okay, a concept of hiding the information, and it's there are different methods in quantum technology. Okay, so we have given some things like lattice based cryptography, hash based signature cryptography, code based cryptography, multi level based cryptography. So this cryptography is nothing but a way of hiding the method of hiding the information, that is there's some data. Okay, so we will be having different cryptographic concepts in quantum technology. So we are when you are making the two or three combination, so we are if you are using two or three combination concepts, then it will become a hybrid. Okay, so that is a good quality of protection to the system. So and the thing is, in quantum things, security is a matter. Security and storage is a matter. This make very cryptographic. That, for example, this lattice cryptography deals with the 3D, three-dimension things, three-dimension grid. Okay, and it's a protection key for the hidden key will be there. So whenever you are storing the information in a computer, it will be stored in some address. Okay, there is a two different types of information in the computer. One is data, one is address. Okay, address is nothing but data is nothing but a storage information, whatever you are going to the computer. The address is nothing but where the location the information is going to store in the computer. Okay, for example, we are storing in the RAM, ROM. Okay, some data is running in the RAM, some data is stored in the ROM. Okay, where these data are nothing but is a storage, right? Some different address locations. There will be some different address allocations. So each address location having some information that is called data. Okay, so the data will be easily hacked when if you know the address of the device. Okay, if that every device having IP address also. IP address is internet protocol. As you know that if you know the internet protocol, you can easily enter into the device information. Okay, so similarly, in lattice cryptography, we are hiding the data with secret keys. Okay, in this, we are hiding the data in secret keys. And hash-based cryptography, we are hiding with the like fingerprint and digital password-based information. Okay, this is like password-based information, and this code-based cryptography is nothing but hiding a lot of complex error correction. So if the person need to hack that information, he has to solve the complicated task. Okay, that complicated task is not complete in the fraction of second. It will take a lot of time. Okay, so the person when he is going to solve the first stage, then the next stage will be, and next stage will be having some other task. Okay, and in quantum technology, and data is not centralized. Okay, data is decentralized because it is stored like blockchain technology. By using blockchain technology, we are not using the centralized data. We are using the decentralized data. So because if you store the data in single point, single location, it is easily can be hacked. Okay, But if you store the data in multiple storages, multiple locations, it's not easy to hack. And in blockchain technology, like in whatever you are using in blockchain, which is currently trending in blockchain, once the block is made, you can't make it rewrite. Okay, you can't rewrite the block. It is the data is also decentralized. Okay, similarly here the in quantum data is not it is centralized. It will be also decentralized. It is multiple location storage. Once the person is enter into the one, the next data, one data is here, one data is somewhere. Okay, you can't go on making to crack all the information. It is very typical for the hackers to crack that information. So NIST PCQ standardization process. So in 2023, and Crystal Cyber is a different methods of uh, like algorithms you are using. Okay. So the major key advantages of the quantum key distribution is security fundamental physics. Okay, this is rather than, so we are not concentrating on the hardware complications. We are concentrating on the software security only. So in quantum computers is a quite different structure. We are not going to use similar hardware and similar software there. It's a quite different structure for the quantum computers. In traditional computers, we will be having some processors. So these processors will not be work. This environment will not be support for the quantum computers. Okay, and every technology there is some limitations. Every device, whatever you take, uh, they work. The devices will work with some limitations because they are designed on the in their own parameters. For example, we are using different laptops, different mobile phones. All the mobile phones having same appearance. Physically, they look to be same, but internally, whatever the hardware they are using, whatever software they are using, is quite different because um, some some may be depend upon the processor, some may be depend upon the storage, some may be depend upon the resolution and battery. So similarly, every based on the design of the hardware and the software, the performance of the device will be depends. Okay? So the limitation of these, for example, if I use some mobile phone, i3 or i5 laptop, i7 laptop, so they are if you use same task to the different processor, they do the task with different time periods. Okay, because the time period, the speed and the execution speed of the device will be different from the each and other, because i3, i5, i7, the bit rate and the frequency will be quite different because they are designed in their parameters. Okay, so based on this parameter, there will be some limitation to each system. Okay, in this quantum technology also, there will be having some limitations. We can overcome that limitations in future. Okay, we can overcome by step by step. We can overcome that limitations in future. So this is a slide which can be which can differentiate both classical PQC and blockchain PQC. It's a combination of two more technologies and make multi-hybrid. Hybrid is nothing but a combination of two things. Okay, like hybrid materials, what you are using right now is a combination of good two parameters. We are combining two things and making the better one. Okay, we are having classical PQC and blockchain PQC and QKD PQC and multi-algorithm approach. Okay, and this approach, the classical PQC is layering the current algorithm and post-quantum algorithm. Okay, these are clubbing two algorithms and making this classical PQC. Okay, and blockchain PQC is decentralizing the information. So we are not storing the information in this particular storage. We are making decentralized the information. And in QKD and PQC, the physical quantum security, key security, we are hiding the information with the combination of different secret keys. Okay, this is not is a particular thing in the stored in a particular place. Okay, we are decentralizing. Even if the person is going to hack that information, it is a key secured. So everything, every bit, every data, every information, bit by bit or byte by byte, it may be key secured. Okay, and multi algorithm approach. Okay, so we are clubbing all multiple algorithms. We are clubbing all multiple algorithms and making the standard algorithm work. Okay? So based on that, the potential breakdown of the quantum attacks will be increased. So the security will be increasing to the quantum computers. So zero trust with the quantum systems. Okay. So zero trust of quantum systems is nothing but there is no security. If the what happened if there is no security. Zero trust means no system is secured. Additional quantum safe authentication test, privilege and continuous monitoring. Okay. It is continuous monitoring. If the system is no security, if somebody need to monitor continuously. Okay, so that only to avoid the problem of monitoring, we are introducing different algorithms for protection and different technologies such cyber security and blockchain system, and all those are we are introducing to avoid the or to overcome the problem of security problem. Okay. So if there is no trust, there is no security, there is no safe for the device. And continuous verification, least privilege, and comprehensive monitoring. So if there is no trust, there is no security, we need some continuous verification. So we have to monitor the system continuously. We have to check the system continuously, and we need least privilege and comprehensive monitoring, real-time threat detection system monitoring for both classical and quantum-enabled attacks. Okay, so there should not be a system like zero trust architecture. There should be a system like every 100% trust. Okay, in quantum methods. Okay. AI enhanced quantum security. So now we are in a trending position like AI. We are using different AI tools. Okay, what is like AI? Artificial intelligence. We are the natural intelligence. Humans are having natural intelligence, which is given by the God. Okay, but in AI, we are making artificial intelligence. Artificial intelligence is nothing but a method of training a device. Okay, a method of training the system or a method of training the computer. Okay, it's artificial. Giving the information. We are giving the information to train the system. Okay, like Chat GPT we are using is an AI tool. Okay, it's not complete AI. It's an AI tool. It is having some AI. It is giving some suggestions. It will give some information. It will give some guidance. Okay, based on its trained data. So this AI depends upon the train and testing. So training and testing. Okay, so we have to train the data and we have to test the data. Training means you are giving the standard information for training the mission, and we are testing data. So how they are going to response to the question. Okay, and it is also enhanced with the quantum security. Okay, it can be enhanced with quantum security because whatever the things we are doing, that the human intelligence is more than humans. It can do by the AI. Okay, that the operation period, that means performing the mathematical operation, performing the logical operations, performing the any digital task, any visual operations. AI can be done much faster than humans. So if we are going to involve the AI into the quantum security, AI power defense in anonymous quantum power attacks patterns and adaptive cryptographic parameters optimization and automatic security posture adjustment to merge threats. So these things can be defense. Okay, and security risk at the same time security risk also will be there. So quantum machine learning accelerate the vulnerabilities discoveries and like vulnerability discoveries the methods of attacking the system. Okay, at the same time AI has good to the humans, and there is also some threat from the AI also. Okay, even many AI tools are generating some biggest warning from the scientists to stop the research on to stop the research on AI, because it will create the security and same like it will leak the secrets also. There is chance to leak the secrets. So these AI, when quantum is involved, when AI is involved in the quantum, the machine going to accelerate the vulnerabilities discovered. The number of attacks it will also invent. So the number of way of method of hacking the system also it will create. Okay, there is some problem with that system AI security, but uh, why even though we are having the some threat from the AI, why people are introducing the AI? Some extent, AI is good for the humans. Okay, uh, if you train the if you give the most information, most complete information to the AI system, it may be threat to the humans. We are training the system with some limitations. Okay, like um, you are not going to provide all kind of information for the single device. Okay, if you give the single device, it will act as a smart. Also, because it is in AI algorithm, the system can be trained itself. Okay. It will learn from the nature. So we are training some extent. Then the other extent, it will train itself only. Okay, it will able to rewrite its code. It able to modify its code. It will able to generate its code. Okay, AI is having the capability of rewrite the existing code. So what we are giving some software instructions. We are giving some software instructions, and it can able to rewrite the its own existing code. Okay, our computer cannot do it. Okay, if our computer is if our computer is AI smart generated computer, it can able to boot its own OS. It can change its own motherboard instructions. Okay, it can able to control its own. Okay, in AI that is the problem. When the AI is going to change its own data, it is able to learn most information. So with that only, the threat will be there from the humans. So in same like there are some precautions to avoid that also. So so that only scientists are going to work not to train AI in a much extent. Okay. Similarly, because some AI tools, if you are creating the image, recently our PM sir also said that AI cannot do all creations by its own, because he said that create a image with person writing with the left hand, but the AI is created person writing with the right hand, because the system has trained that as based on that image. Okay, the system has trained that based on that image, the AI tool is working. And next thing is uh, security in IoT quantum era. So IoT, it's AI, IoT, everything are the latest trending technology. IoT is what is IoT? IoT is nothing but a all the devices can be connected to internet. Okay, all those devices like previously in 20s, like 2000 year, uh, 2015 above, like all there are smart devices only like smartphone and laptops. Okay, now we are having smartphones laptops, smart fridges, smart TVs, smart ACs, and smart vacuum cleaners, robot cleaning, everything. All those things are working with their uh, own decision. Okay, so you, like in previous years, if you want to, if the fridge is like we are think that the smart fridge is automatically cool down the temperature based on the outside environment. Okay, and smart ACs based on the environment temperature and pressure, it will control its own settings. Okay, and smart robo cleaners we are using in homes. Okay, they are controlling the automatically they are taking the decision, cleaning the system and making itself torched. Okay, all those things are running with the AI, like IoT only. Okay, IoT is nothing but a device which can be connected to internet and communicate the data with cloud. Okay, for example, all my home is IoT device operated, so I can control this system with anywhere. Okay, I can control the devices from anywhere. Okay, so that means I can on the data, on the system, off the system, and control the system, monitor the system from anywhere. Okay, but is there any security that the third person should not hack my device? Okay, I need to. I have to only switch on the light. I have to only switch on the light of my home. Okay, third person should not be done. If the system is smart, okay, the system is, somebody can hack my system and on my TV or my AC. If that is a misuse, right? So there is some threat from the threat for the IoT devices for uh, in quantum era. This can be overcome. Okay, and there are many lack of storage also. Okay, so for example, I'm monitoring the temperature of my home. So all the data is storing in the cloud. So continuous monitoring makes large data. So how we are data is storing in the big servers. We are companies are maintaining big servers and big clouds, and they are maintaining. They are investing lakhs of rupees. Now to overcome that, we are introducing the big data also. Big data is that we are compressing the information. Okay, compressing the information. But is there any security? There is no. We can't show that in quantum era. There is not. It's not easy to hack that information. Even the big data is also stored safely. Even IoT information also stored safely. Okay, and challenges is billions of things are connected to internet. So in IoT, billions of up to now. So 2025, 50 billion things are connected to internet. Okay. For example, what right now we are having this session. All our computers and all our mobile phones are connected to internet. Okay. At current generation, 50 billion things are connected to internet, and we are communicating the information from the system to system. Okay, all billion things are connected to internet. Is there any so that means data is passing to the internet? Is there any chance to hack this data? There is lot of chance. Okay, there is no security. So even we are having some protections or encrypted information in encrypted protocols, but we can't assure that the data is safe. Okay, because some humans has to be some human has to be uh, controlling the information. Like right now we are using Google Meet. So who is going to access this information? Google can also access this information. Okay, we are trusting the Google blind. Okay, so we are depending upon the human soul. Okay, if there is any chance that Google also can misuse this in case, but in quantum era there is no chance like that. Okay, even the billion things are connected to internet. They are secure and safe. So quantum safe cloud security. So I'm telling same thing only. So they are using AWS, Amazon Web Server, and different servers are there, web servers are there. Google Azure. Okay, these are the clouds, and Amazon Web Servers is a different cloud. So these people are giving as a storage. So for example, Google Gmail we are using. So we are sending Gmails. How where the Gmail is data is storing with the Google on the Azure. Google is having their own servers. Azure. Okay, they are storing. They are also maintaining the others information also, like other company information also. We can buy the information. So like AWS, Amazon clouds also we can buy. Okay, but we have to trust the Amazon blindly. So how far your data is safe? Okay, we are trusting the Amazon blindly. We are trusting the Google blindly. Whatever the IBM, different what is different companies are providing the clouds, but how far we can't assure that is there any chance to have they themselves can make the hacking of their data. Our data is with them. There is chance to hack by them also. How can we trust them blindly? So there is some problem with that. So all those things can be overcome in uh, what is quantum technology, because even though we are hiding the data with them, they are encrypted. It is not you are encrypted, and we are making the data encryption, or we are making the data decentralization. If the person is entering to our personal information data, it will be known to the person immediately. So, and there is no chance, because every time it is changing the keys. So for example, if I save my mobile information with some password, so third person is going to enter, automatically the system is changing the keys. Okay, if it is not easy to decode. Okay, it is not easy to decode, because key is not constant every time. The password is not constant every time. It is keep on changing. Only the authorized person can be enter the right person, right key. At the time only you can access the information. So, which are the industries mostly facing this issue? Regular landscape standards. Okay. So in nowadays we are using the internet in all the sectors, like government sectors, industry sectors, and other companies and frameworks. Okay. All those we are using the information, but everywhere we are having uh, cryptographic threats. Okay, that means data security issues only. Okay, all the government is having much information of the country. Okay, and government budget oriented, and army oriented, military oriented, and defense oriented information will be there, being having secret data. If there is a chance to hack the data also. Okay, there is a chance to hack the data. Government mandate the quantum deadlines. So they has to make it security. Okay, in every industry also making security, and every framework also needs some security. So these are the regular facing issues. Quantum powered quantum powered cyber attacks. What is cyber? Basically, cyber is nothing but internet. Cyber is nothing but a internet. So it is making some, it is having some issues. Okay, internet. So most of the things are happening. Attacks are tracing from the internet only, because all the devices, IoT devices, all the IoT devices are AI devices. They work on the internet only. So the medium for the changing the data from the system is the internet. So there's a different way to access the internet, like Wi-Fi's, mobile phones, mobile data, lands. Okay, all those things are accessing with the internet. Okay, so there is a cyber attacks maybe merged with the quantum attacks. We can also overcome the risk, the new risk, including the description, broken the signature, or quantum ML powered vulnerabilities. Okay, all these can be attacks can be overcome. So vulnerability is nothing but types of attacks. Okay, we are having multiple types of attacks, right? That may be cyber based only. Okay, quantum side channel attacks, quantum ML attacks, re- restro respectful description attacks, and cryptographic breaking. Okay, all the cryptographic breaking is image. We are hiding the image, or we are hiding the information into the information. Okay, digital signature, certificates, everything. These are cryptographic based only. Okay, images that may be different formats, PDF or any. Some nowadays we are sending. Some people are sending a photo, a image in a WhatsApp. If you download that image, automatically the backend encrypted software will give the personal information to the hacker. The every data will be going to the hacker's hand. Okay, somebody calling with you, making the calls, or somebody sending the messages, somebody sending the images. So there are different ways for the cyber attacks. So crypto electricity key quantum readiness. Okay. So crypto electricity means a system to can swap the algorithm quickly. Okay. Swapping technology. So even though we are having some swapping methods in software also, swapping is only changing the information, build the abstraction and layering the centralized management. Okay. So so cryptographic invention is comprehensive mapping of the crypto assessments. So we are changing the swapping the algorithms. So interchanging the even there is not sequence. So sometimes we are using first algorithm, and in the next method, that first algorithm will be in the third or second position, or maybe a last position. So there are different merging, that is different way of mergings and different way of slicing, swapping the algorithms. Okay, and because if there is in a standard sequence, the person can be easily learn learn the methods, and he can easily hack the process. Okay, so for that only we are swapping the algorithms, and automatically sometimes they will swap itself also. Okay, automatically they can swap itself also. The first algorithm can be in the last position, the last algorithm in the middle position. Okay, based on that, that the person who is going to hack that key is not able to retrieve the data. Okay, so this is centralized management. Implementations and challenges and solutions. Okay. uh, every aspects, every sector, there is a chance of some challenges, and there is some solutions for that. So everything in any domain you can take, any sector you take, there is some common abstract and practical solution. We need some common obstacles. They need some practical solutions. And similarly, we are also facing some common obstacles of, and it needs some practical solutions. Okay. Abstracting maybe legacy systems, performance, dependency of the solution, crypto chains, and API key gateways, hardware acceleration. Okay, these are the different things are there. So like hardware acceleration. So by using, if you are using nowadays computer, the day one you buy, it will work perform very smart, very fast. After 10 years, the performance of the hardware will be decreasing. Okay, the performance of the hardware will be decreasing. We are not doing anything, so we are just using the system for a period of 5 years or 6 years or 10 years. The performance is automatically decreasing. Why? The day one, whatever you buy, the same things are having inside the system, inside the hardware is same things, but why its performance is reducing? Why its performance reducing is based on the environment. The hardware components will be getting losing their strength. Okay, the hardware components in a certain period of time, after a certain period of time. Okay, for example, if you are having the, if you buy a car, okay, So in the first day or first year, its performance will be very high, very fast. After 10 years, the performance and its condition will be becoming weaker. Okay, so it's a common thing in every technology, every industry. There is some having common obstacles and there is some practical solutions. Here also, we are having common obstacles like key signatures performing and third party dependency. There is some third party dependency. You have to trust some other companies or some other people for making this system security. Okay, and the practical solution is API key gateways. So we are using the IoT devices. So every IoT device we have an API key. API key is nothing but an application program interface. Application program interface which can be accessed the gateways. Gateways of the internet is Wi-Fi and GSM and mobile data and LAN connections. So these are we are using the internet. That are the gateways for the internet. There is chance to some challenges to make them protect. Okay. Quantum safe migration map. Okay. Quantum is a mapping, is a roadmap for the quantum safe migration mapping. Four stages we will be having: assignments, operation, preparation, implementation, ongoing the operations, and being 3 to 5 years before the grade. Okay. So first 6 months to 12 months, we are making the cryptographic inventory, risk assessments, data classification, and by quantum vulnerabilities, dependency mapping. So this is a roadmap for step by step approaching the perfection in the device. Okay, there is no. We are estimating the time period. It is not constant for every system. Okay, we are estimating the time period. It is not constant for the every system. In some cases it may be changed. Okay, in some scenario it may be change the time period because vulnerabilities may not be constant. So every time it may be new because there are different ways. There are some limitations to identify the things. Okay, so cryptographic inventory also is not standard. So there are different ways. We are making perfection in that. Okay, it may be take the time period of 6 to 12 months. Preparation phase also it takes 12 to 18 months. It's not we are estimate is not expected time period. Okay, it's not estimated time period. It is expected time period. And implementation phase also to make it means 8 to 36 months. We are 18 to 36 months we are given, but it's not completely. It's expected. It's not estimated. So to make those things perfection, it is taking little time period. So next thing is building your quantum safe security, key role and responsibility. The key role is nothing but security architect, PQC specialist, and cryptographic validation, building the capacity via training and partnership. This the quantum security architecture may be design overall quantum safeguards and infrastructure. Okay, this is nothing but key role. The major key roles is first priority is security architecture. The initial the initial things should be a security. Okay, before implementation the after implementation the complete device, if you require security, there is waste of time. Okay, before that only we are you make the security. We have to make the security and safe and strategical infrastructure. Okay, and the next thing is PQC implementation specialist, handling the technical integration of the quantum assistant. Okay, we are post-quantum computing. In post-quantum computing, we have to integrate the quantum resistant algorithm. We are implementing the quantum resistant algorithm and cryptographic validation. Cryptography is data security, which it may be image, it may be a data to data, image to image, or image to some other videos, encrypted, and building the capabilities. Partner academic institutions. So we are spreading the different industries like development, internal training program, and post quantum cryptography. Considering the special recruitment of the consultancy of ancient experts. So key takeaways. So so it is when to start, where to start, or how to start. So start now. So that is this. It is beginning stage, not later. So if you are keeping the keep on postponing or keep on developing the system postponing, it will be too late. Okay, it is the right time because we are introducing the new technologies, right? It is the right time to make it develop and um, you should not make it later. Okay, the quantum threats timeline may be a migration complexity, demand early actions, beginning with the inventory and crypto agency fundamentals. Okay, so you have to start now only and adapting the different in future and build flexibility. Build flexibility. Start early, adapt hybrid models. Hybrid models. Hybrid models we are using is we are merging the multiple algorithms, designing with flexibility and security leadership support. Okay, all these all have to merge together and make the perfection in the system. Quantum safe security implementation and critical error. Okay. Overall concept overview is protecting the information. The main thing is protecting the information. Okay, the information is nothing but a data which you are storing, and whatever your issues you are facing in the traditional computers. So whatever you are facing the problem with the existing computers, that should not be happened in the quantum technology. Okay, so for that only we are making the initial step as a security. So the overall thing is we are protecting the security barrier for the information. Okay, we are protecting to reach the information. The person has to risk multiple tasks. Okay, multiple tasks they has to face. Why quantum safe cryptographic matters? Okay, so quantum is safe because in digital computers there is a 0 and 1. Okay, in digital computer there is a bit can be a 0 and 1, but in quantum computers we can't estimate it is a 0, a bit is a 0 or 1, we can't estimate. It can be changed its position. That is called superimpose of the system. Okay, superimpose is nothing but a system can be exist here and somewhere. Okay, that is the typical thing in quantum technology, because a system it may be a positive or a negative. We can't estimate in the computer. It is a low or high. We can't estimate. In digital computers, we are using low and high. That is 0 and 1. Okay, digital is 0 and 1. But in a quantum, we can't tell that whether the bit is a 0 or 1. So it is highly protective. So the person may not be that a human is not easy to crack that things. Okay, even the AI system also is not able to crack the thing. Okay, because AI should be trained perfectly only. If you train perfectly, then only it can able to crack the device. If it is not trained perfectly, nobody can estimate whether it is a positive logic or negative logic. So timeline for quantum thread. Next thing is timeline for quantum trading. NIST standards by 2024, relevant quantum systems is by 2025 to 2030. Okay, so this is the procedure for approaching the number of how many years to overcome one by one step, one by one step to approaching the quantum. NIST PQC standardization process is narrow in 2019 to 2022. In 2022 to 24, first NIST standard published. Okay, that is a publication based. Okay, introducing based. Early adapter of being the integration. And 2025 to 28, possible emergency of cryptographic relevant quantum computers. Okay, so recently in Andhra Pradesh also, they have started Quantum Valley. Okay, so previously into 2090s, when we are in the childhood stage, the software is a boom. We are the first software in 1990s. Now we are entering to software technology like traditional computers technologies to quantum technology. It is now upcoming 2-3 years. Quantum will be building very gradually, building very demandingly. Okay. 2025 to 28. Recently, Andhra Pradesh is started Quantum Valley also. They are working on quantum computers. Our Honorable Minister Chandrababu Naidu, AP Chief Minister Chandrababu Naidu started Quantum Valley. So we are having Silicon Valley, right? Now we are having Quantum Valley in Andhra Pradesh. So project objective is nothing but either our project objective is identifying the vulnerabilities. Okay, finding the vulnerabilities, finding the threat for the quantum. How different types of threats, how many way of threats for the quantum we are finding the vulnerabilities, and audit system and digital PQCs. Designing the PQC. PQC means post quantum computing. We have to identifying the threats. Okay, and implementing the prototype. Now we are stage of implementing the prototype. Prototype, as you know, we can't implement the real system directly. Should work on the prototype at beginning stage. Later, a prototype can be a real-time device. So a prototype is a small example for the real-time world. It's not a complete real-time device. It's an example for the real-time world. If you work some limitations or whatever facing the prototype, it will be overcoming in the real time. Okay. And accelerating security and performance. We are increasing the safety and performance. We are the impact of performance. We are testing the performance of the system in a prototype. Technical stacks and resources. So which are the companies working on the different things is like IBM Q, Microsoft Q, QAsh, ILOps, and Decretum, and different companies out there. They are working in a very hardly with the research and development of quantum. They are working with the post-quantum algorithms and implementing the libraries also. Recently, they are implementing the open quantum safe and different testing tools for the quantum computers. So high value use cases. High value use cases. Why high value? Very value for the quantum security is quantum in financial sector, in healthcare sector, in defense sector. Mostly, any country is having financial services. The wealth and everything are stored in strategic are stored in financial sector only. In health systems, also a country's health or a country people's health in their healthcare systems. So there is also some securities and defense systems. So these are the major industries which has to be important for the securities. These are the financial first because money matters more, right? Money makes many things. Like similarly, if the financial system is not secure, there is no protection for the any individual. There is no protection for any industry. There is no protection for the any country. Okay. It's similarly healthcare sector. If the healthcare sector, if the sensitive data of the humans is misused, okay, any hospitals or any healthcare, so if it is misused, there is chance of bio wars. Like recently we faced corona. Okay, corona is a kind of like people are saying like end of a bio war. You say if there are any medical issues, they can easily implemented. And the defense industry. So defense communication also, the secret information between the country to country take place, military to military take place, right? If there is any that means number of defense systems of missiles or some other things. This is very conspiracy information, very secure information. We should not expose to the other world. So it is very secret. So we have to communicate, and we are making some communication between the different communications. Like any secret agencies may communicate the information. If there is some security also either. So project methodology is having 4 stages. Okay, in generally, first stage will be problem definition. We have to know what you are going to design. You have to know what you are going to what you are going to face the problems in designing the system. That means vulnerabilities of cryptographic system or in any design. And the stage is next stage is design. Design stage. We have to approach the uh, what are our target columns, what are our targets. We have to make a point of targets, and we have to design a system. Then we have to implement the prototype. So before introducing the real device, you have to work on the prototype, because prototype will teach you many things. Without prototype, we can't make any thing. We can't make. If you make it, is we can make it, but if any issues are there to overcome, if you have to dismantle the complete real-time device, it makes a lot of investment. Okay, now to avoid that, every research industry or every industry, they are looking for first they work on the prototype. If prototype is solved, 99 problems, solutions will be there. If they can easily work on the real time system. Okay. Next, evaluating. So evaluating is nothing but a performance, how they are going to perform in a real world. Okay, how they are going to work on a real world. Problem definition. So nothing but it's a problem definition is nothing but a vulnerabilities we are finding and making the success criteria. So identifying the problems and making the solutions. Identifying the problem and making the resolutions. Okay. So like RSA and the ECC are the existing vulnerabilities, existing problem for the traditional. This can be overcome with the quantum technology. And success criteria is working on a vulnerabilities is automatically the device will make 100% performance. So design phase is nothing but algorithm selection. So way how to approach the algorithm, which algorithm is used for particular task, which algorithm is used for particular you know, things is we have to design first. Then we have to design the architecture which are involving the integration of points with existing infrastructure. We have to differentiate both the existing and proposed, and what makes the difference for the existing and proposed. And we are working from protocol modification for new algorithm. Okay, and next security modeling. Security modeling also. Uh, Security modeling, so how they are capable to work with real timeline. Okay, how they are going to work in real-time scenario. So we are the different protocols we are using currently. Document signature, HTML, HTTP protocols. Okay, and so these are the sectors. So facing the different threats to the current traditional computers will do. Okay, like IoT and embedded systems having some problem, and even software protocols, HTTP protocols also having some problems. There is a security problems, so they can be considered very high security in future. Okay, so even though we are monitoring the system, every system, there is a lot of investment, lot of time period, lot of manpower required. Okay, this can be overcome in phase three. In phase three developing process. So after knowing all those things, we can easily uh, develop the process, like how to design the libraries, how to identify the web the algorithms, and develop the management, and how to create the prototype designing and hardware assembling and testing and security validation. So implementing the code, okay, evaluating. So after designing the computer system, evaluation is much more important, because after in every aspect, in every aspect, every sector, there are some how the system. We have to test how the system is working. We have to test how the system is working. Then only we can test on it. Then only how the security analysis performance or benchmark enterprise and encrypted system will be. We have to test it, performance. Okay. So for that only we need some evaluation. So this is the differentiation. This is a bar graph of the how traditional computers or quantum algorithms will be differentiate, how they are working the performance and how they are used in the real time scenario. This is a bar graph differentiation. Banking transaction migrate. So usually, most of the cases, banking sectors face most issues like financial issues. We need some use cases. They are facing some challenges in like financial institutions need to secure their transaction validation. So every transaction is monitored, every transaction is stored. They are having multiple authentications. Okay, so for example, we are using all the UPI keys, UPI apps like PhonePe, Google Pay, and different UPI codes. All are the not related to banking. So you like PhonePe is not a bank, Google Pay is not a bank, but they are taking the money from our banks. So how far they are misusing our data? Is there any chance to misuse the data? How can we trust them? Okay, there is a chance to these are not the banks. If you kept the money in the bank, our account number, our ATM numbers, all the data is with all these UPI systems. Only the transaction is NPC, the National Payment Corporation will be monitored. So from which bank he has to debit the amount, that NPC is act as a mediator between the UPI and banks. Okay. So these are the challenges facing the financial institutions, financial and banking sectors. Project deliveries. So final technical report, working on the prototype, presenting. So usually every project, first we have to make a work on final technical reports. So what are the hardware, what are the software, what are the algorithms, and what are the procedure to occupancy, and what are the problems that we are going to face. We have to make the report. Then we have to work on the prototype. Prototype means developing a small system, okay, and generating the and writing the source code and creating the hardware implementation. We are running and testing the prototype. Next, presentation of the materials like real time scenario. If there are any problem cases, we are presenting the real time scenarios. Implementation and challenging migrations. So what are the implementations and while implementation we are facing some common challenges like algorithm immunity and like algorithms, how far the algorithm is working perfectly and how the system is performing good, and integrating the integration of complexity, hardware complexity, maybe software complexity. There are two complexities will be there: hardware complexity and software complexity. If there is any hardware complexity, we have to integrate into the smart device. If there is any complexity in the software, we have to implement the logical operations. That means software capacity, software storage, software security. It's a software in complexity integration and migrating the strategies hybrid. So implementing the high security and with the high advanced algorithms and advanced methods. We are making hybrid cryptographic logistics, and we are designing the architecture, and the regular system is protecting the threats. So all these things are some implementing the challenges for the any device every day. And next step to resource. So we have to find the resources and its complications. Okay, we have to find the resources and complications, and we have to identify the problems, and we have to rectify the problems. We have to overcome the problems step by step. So because every system have some limitations, every device will be having some limitation. As usually, a quantum computer is quantum system, quantum technology having some limitations. Okay, so in the matter of any environment, in the matter of any environment based or any hardware based or any software based, some limitations will be there. So we have to overcome some limitations, and we have to make the existing problems. We have to solve the existing problems and make the perfection. So the most important thing in introducing the quantum technology is high performance, high accuracy than the existing technologies. Okay, they are more secure, they are more performance than the existing, thousands of times faster than the existing devices. So now we are so that only we are working on the quantum technology, and they are safe and secure. So this is the overall thing is, and safety and security of the devices. I hope all the people are got some clarity of safety and security of the quantum systems.
Yes, sir. Thank you very much, sir. Your session is very informative.
Thank you
Yes,
so much.
all the participants, if anybody want to ask the questions, speaker is available. Unmute yourself and can ask the questions.
Anybody having any question, any queries related quantum systems?
Sir, I think nobody have the doubt. Sir, thank you very much. Your session is very informative. And the inputs what you have given definitely enriches our knowledge in the domain of quantum computing as well as security. Thank you very much, sir. Thank you.
Thank you, everybody. Thank you so much.
Thank you, sir.
Shall I leave the session?
Yes, sir. Yes, sir. Thank you.
Thank you so much.
Yeah. All the participants, today's session's feedback link is available in the chat box. Please submit it. And Our next speaker is already joined. So without wasting the time, let us start the session. It is my privilege to invite our next speaker, Mr. B. Vivek Kumar. He's a security engineer with over 15 years of industry experience. Currently working at Magnex Software, Hyderabad. He specializes in cybersecurity solutions, network protection, and data security frameworks, ensuring safe and reliable digital environment. With his deep expertise and practical insights, he continues to contributing to building robust and scalable security systems for modern enterprises. I would like to invite Mr. B. Vivek Kumar, sir. Sir, welcome.
Yeah,
Over to you, sir. Thank you.
yeah, thank you, Sirajuddin Garu. Yeah, hello everyone. Good afternoon to all of you. Yeah, my name is Bogo Vivek Kumar. I am well and I hope you will also well. Yeah, can you hear me, guys?
Yes, sir. Your voice is clear, sir.
Okay. Uh, Today I am here to tell you something about quantum computing and AI convergence. But first of all, I would like to say thanks to who gave me golden opportunity to speak in front of all of you. So thank you. So let's get started. I will share the screen. Yes, is it visible?
Yes, sir.
Yeah. So today's session explores the intersection of quantum computing and artificial intelligence. So together they promise to reshape industry's cybersecurity and scientific discovery. For example, we take as quantum enhanced AI cloud, right? So could reduce drug discovery for discovering of drug timelines from years to months only. Within shortest time, it will reduce. Okay. So today our agenda is quantum computing state of the art, quantum software ecosystem, quantum convergence, and future implications. Okay. So we will cover all these areas today.
Sir, sorry to disturb. Your PPT is not visible.
My PPT is not visible.
Yeah, please share it again.
Okay. Yeah, can you see my screen? Yes, is it visible?
No, sir.
No. Okay, wait a while. Yeah, I think now it is visible. Yes?
Yes, sir.
Yeah, okay. Yes. So today our agenda is quantum computing state of the art and quantum software ecosystem, AI quantum convergence and future implications. So this is our agenda to we will cover all these four areas. Okay. Yeah. First, quantum computing landscape today. How quantum computing is getting progressed from it has been progressed from theory to practice. Commercial systems operate 50 to 126 127 qubits, while laboratories are pushing beyond 1000 qubits. Nothing but scientists are uh, pushing up to 1000 qubits, but our commercial systems are 50 to 127. So while still we are noisy intermediate scale quantum, we are witnessing unprotected progress in hardware reliability, nothing but. So not we are in NISQ era, limited but rapidly improving. It is rapidly improving. Okay. Next, there are three main hardware models, nothing but superconducting qubits, trapped ions, photonic systems. So IBM and Google people are using superconducting qubits, and IonQ using trapped ions, and Xandu photonic systems are using. They are using. So each has their own strengths in scalability, coherence, or natural error resistance. Example, nothing but IBM's 433 qubit Osprey processor shows industry scale progress, nothing but. It is showing industry scale progress. IBM example we have taken. So next, so quantum error correction, the path to fault tolerance. So nothing but quantum systems are fragile. Error correction ensures practical reliability. Breakthroughs include logical qubits outperforming physical qubits and 99.9% syndrome detection accuracy. So we can detect errors within 99.9% accuracy. Okay. Next. So hardware scaling, how we are scaling, nothing but we have just seen 50 to 127 qubits. Today's system, every industry is using up to 50 to 127. But laboratory prototypes are using 1000 plus. But fault tolerance up to needs 1 millions, nothing but. Okay. Bridging this gap is industry's biggest challenge. Nothing but. Okay. Next, coming to quantum software ecosystem, quantum software is advancing as fast as hardware. So just now, see, we have seen three, right? See, these are three. So software is advancing compared to hardware. So those programming languages are nothing but Kisbit, nothing but used by IBM, QSharp, and Kirk, and quantum assemble language standardization. These enable circuit designs. So these programming language enables circuit designs, hybrid execution, and cross-platform support also they will support. Okay. Next, quantum cloud services. So what quantum cloud services are? So cloud platforms give remote access to processors, simulators, and development tools. Okay. So these will give remote access to processors, simulators, and development tools. Over 4 lakh users are registered. Accelerating the ecosystem. Examples: AWS, nothing but Amazon Web Services bracket, and IBM Quantum allow global researchers to run real experiments without owning hardware. So they are using only these softwares only. Okay, programming languages, right? Next. Right. AI quantum convergence. So we will see two transformative technologies entering a powerful symbiotic in relationship. Those are AI and quantum computing. AI improves what quantum algorithms and hardware control, and quantum accelerates AI training and optimizations. So quantum for AI, nothing but it will accelerate AI training and optimization, nothing. And last, these together, hybrid systems tackle intractable problems. So it will tackle with intractable problems, nothing but. Next, AI enhancing quantum computing. So AI helps with circuit optimization, quantum circuit optimization, up to 20 to 40% fewer gates, nothing but. Okay, error mitigation 2.5x fidelity, automated calibration for stable systems. For stable purpose, we use automated calibration. So it is an AI enhancing quantum computing, nothing but. So here we need to see case studies. What are the case studies? So algorithm, AI optimized quantum algorithms, nothing but Google AI used reinforcement learning. So it will use reinforcement learning to redesign quantum approximate optimization algorithm. Results 36% reduction in circuit depth. Circuit level, it will check nothing but result up to 36%. 2.3x improvement in quality on noisy hardware. So nothing but 2.3x up to will check. So for example, AI discovered non-intuitive designs outperforming human design quantum algorithms. So AI design, nothing but. Okay, next. Quantum computing enhancing AI. So quantum helps by faster training with quantum linear algebra, uh, and quantum neural networks needing fewer parameters. So these needs fewer parameters and combinatorially optimization for future selection purpose. So example, D-Wave systems have demonstrated 100x speedups in graph-based ML, nothing but machine learning optimization. Okay, next. So emerging applications of quantum AI convergence. So promising areas include drug discovery. So drug discovery, nothing but molecules, that type. So quantum simulation plus AI prediction purpose, we use this drug discovery. And financial modeling, nothing but portfolio optimization purpose. And climate modeling, improved forecasts. So improvement of forecasting the climates. So we use this quantum AI convergence. Next, quantum AI convergence for cyber security. So there is cyber impact, threat quantum cryptanalysis. So here we are using source break, RSA and ECC. And next, defense quantum resistance cryptography, nothing but PQC, we can call it as post quantum cryptography, also we can call it as. And opportunity, quantum key distribution and AI based anomaly detection, we use cyber security purpose. So that is the main reason quantum and AI convergence. Okay, next. AI quantum security implications. So emerging capabilities, nothing but adaptive defenses, quantum random number generation, plus AI plus quantum machine learning. For threat detection purpose, we use these security implications. Next. So industry transformation timeline. So industries, how they are transforming their applications, nothing but. Okay. So first, 2002 to 2025, 23 to 25, early advantage, quantum advantages, nothing but they are maintaining rich quantum advantages. Next, what they are transforming from 20 to 25, 25 to 28, hybrid quantum classical solutions they are implementing, nothing but. Next, they want to implement 28 to 32 fault tolerance. So any fault tolerance, prudence applications are available or not, they used to check. Next, 2032, 2032, transformative large-scale quantum AI systems. They are used to transform their timeline like this. Next, strategic considerations for organizations, nothing but focuses on workforce development, experimentation with proofs of concept, and partnership with hardware or software providers. Next, roadmaps aligned to hardware maturity. So these are the strategic considerations for organizations nowadays. Next. So what they are, next, key takeaways. So hardware and error connection advancing rapidly. Okay. Software ecosystem accelerate software ecosystem maturing via cloud. So software ecosystem maturing via cloud. Next, AI and quantum computing accelerate each other. So they are accelerating each other. Next, cyber security risk demand attention, and organizations must plan. So organization has to take a step. So these are the takeaways. Next, the futures of cybersecurity, nothing but quantum and AI will reduce cybersecurity, creating both new threats and defenses. So they are redefining cybersecurity and creating both new threats and defenses. Nothing but okay. Here next, the quantum revolution current state. Now how it is going on. So we are in the NISQ era. Just now we have seen that. So noisy intermediate scale quantum era. So here milestone includes IBM nothing but 433 qubit Osprey processor. So IBM using 433 qubit Osprey. So Google supermassive detect demo, nothing but demonstration. They are demonstrating nothing but, and D-Waves annealers. So here D-Wave specialized quantum annealing systems also they are at current state. Okay. Next, quantum computing principles. So key principles are superposition, enlargement, interference. So superposition is nothing but parallelism purpose. Okay, so here we can see qubits exist in multiple states simultaneously, enabling parallel computation and exponential processing power for certain problems. Next, entanglement, nothing but correlated qubits, and interference, amplifying correct answers, nothing but amplifying correct answers and suppress incorrect ones. So we will detect nothing but okay. Next, the quantum advantage. So quantum advantage nothing but quantum beats classically in factorization sets. So here we are using binary bits in classical computing. So in quantum computing we are using qubits. So we will calculate, so we can get complex problems with how much depth we will use go by. We can find out qubits. By that we can find complex problems also. Okay. Next, AI quantum convergence symbiotic relationship, nothing but just now we have seen quantum boost AI training and optimization. AI enhances circuits error and mitigation and discovery. Okay. Quantum machine learning emergences. So new paradigms they have discovered. Quantum neural networks, nothing but leveraging quantum superposition to process multiple inputs simultaneously. And quantum support vector machines. So SVMs, quantum SVMs, exponentially speeds up for classification tasks. Okay. Quantum generative models, creating more powerful generative AI capabilities. So they are generating AI capabilities, generative models, nothing but. Okay. Variational quantum algorithms. So different algorithms they are using, nothing but hybrid approaches suitable for NISQ era hardware. So nothing but just now we have said noise here, noise intermediate scale quantum era, nothing but. Okay. Next, Shor's algorithm. Just now we have seen there. Shor's algorithm represents the most significant quantum threat to current cryptography. So efficiently factorizes large numbers, breaking RSA encryption, solves discrete logarithm problems compromising ECC. Nothing but threatens 90%, threatens greater than 90% of current internet security protocols. Quantum computers will break much of today's encryption. Nothing but NSA warms. It's when, not if. So it will warms nothing but it will warn. Threatening is greater than 90% of current or not. Internet security protocols purpose. So that's a algorithm, shorts algorithm. Next, the quantum threat landscape. Quantum threat landscape. So here, store now, decrypt later. So there are three risks. One is store now and decrypt later, and next cryptographic agility crisis. So we can call it as lack of crypto agility. Supply chain vulnerabilities. These three are threat landscapes. So here you can see adversaries are already harvesting encrypted data, anticipating future quantum decryption capabilities. This threatens data with long-term value. Okay. Next, cryptographic agility crisis, nothing but many organizations lack the ability to rapidly update cryptographic system, creating extended vulnerability windows as quantum threats materialize. And here, last one, supply chain vulnerabilities, nothing but hardware and software dependencies create widespread exposure as quantum vulnerabilities may exist in core components used across multiple systems. So multiple systems, we can use supply chain vulnerabilities. These are the threats, quantum threat landscapes. Okay, next. So AI quantum powered attacks. So harvest encrypted data, quantum decryption emerges, targeted decryption, credential and infrastructure breach. So the progression from current harvest now, decrypt now, decrypt later. Just now we have seen in harvest now and decrypt later. So those are quantum threat landscapes, right? Tactics to full quantum enabled attacks presents a timeline challenge. Organizations must implement quantum resistant measures before adverse gain quantum advantage. Okay, so these are the quantum powered attacks. Next, AI quantum security solutions. So what are the solutions they are implementing? So here, real-time anomaly detection. So what is it? Quantum enhanced AI systems can process vast security data sets to identify subtle attacks patterns that classically systems miss, enabling preemptive defense. And one more solution, advanced cryptanalysis. So he just now we have seen advanced cryptanalysis, nothing but what is AI quantum hybrids can continuously test cryptographic implementations, finding vulnerabilities before attackers and adapting defenses automatically. So before cryptographic nothing but attacks happen, they are implementing testing cryptographic implementations. Next, adaptive security postures, nothing but quantum machine learning. So they are enabling, what they are enabling, security systems that learn and evolve faster than threats, creating genuinely intelligent defense mechanisms. So these are three security solutions, AI and quantum. Okay. Next, QKD, quantum key distribution. So here ensures key exchange. So how they are exchanging via physics. So already deployed in finance or government with less, sorry, with greater than 100 kilometers range. They are deployed already in finance and government sectors. QKD, quantum key distribution. Okay, next, sectoral impact analysis. So here finance, healthcare, defense and intelligence, cloud infrastructure. So the financial sector faces the highest immediate risk for quantum attacks with blockchain technologies, digital payments and high frequency trading system, particularly in vulnerable. Banks are leading quantum resistant technology adoption. So banks are leading with this quantum resistance only. Okay. Next, healthcare, they are how they are impacting analysis, nothing but patient data with multi-decade relevance requires immediate quantum safe protection, genomic and paramedical research data represent high value targets for store now decrypt later attacks. So store now decrypt later attacks, same. There's no we have seen, right? Next, and intelligence. So here what they are saying, nation states are raising nothing but nation states raising means nothing but advantage, quantum advantage for both offensive and defensive capabilities. Classification systems and communication networks require urgent quantum resistant upgrades. And last one, impact analysis, nothing but cloud infrastructures. Hyperscalers face unique challenges in transitioning massive distributed systems to quantum resistant algorithms while maintaining backward compatibility and performance. Okay. Next, post quantum cryptographic algorithms. So what are they? NIST's PQs, nothing but post quantum cryptographic standardization processing, is establishing new quantum resistant algorithms based on mathematical problems that remain hard for quantum computers. So here they are using three families: lattice based cryptography, hash based signatures, and one more is multivariate cryptography. So those are, we will see one by one. Based on the difficulty of finding the shortest vector in a high dimensional lattice, crystal kyber selected as primary encapsulation mechanism. In this they are doing hash based signatures. What they are used to do relies on the security of cryptographic hash functions. Next, Phoenix provides stateless signatures with minimal and assumptions. So they are using different signatures for cryptographic hash functions. Next, multivariate cryptography. Security based on the difficult of solving systems of multivariate polynomial equations. So they are using polynomial equations to solve those post-quantum cryptographic algorithms in ISTs, nothing but. Okay. Next, hybrid security models. So here transition requires hybrids, nothing but classical PQC and AI monitoring purpose, HSM, nothing but, and layered defense. So these are the hybrid security models. So we will see one by one. Composite cryptography. So combining classical and post-quantum algorithms to maintain backward compatibility while adding quantum resistance. So this is the cryptographic composite. And next one, AI enhanced monitoring using machine learning to detect AI specific attack patterns. So what are the attack patterns we have? So we have different attack patterns, like just now we have seen. See here, store now and decrypt later, cryptographic agility crisis, sub vulnerabilities. So these are the attack. So for that we are using composite cryptography. Next, AI enhanced monitoring using machine learning to detect quantum specific attack patterns. We are using this for using machine learning to detect quantum specific attack patterns. Okay. Next, hardware and software integration. Purpose built quantum resistant hardware security models with adaptive firmware. So here in diagram we can see that. See here, secure core. It is a what are the steps we have seen here? Defense in depth strategy, multiple independent security layers to prevent. See here, multiple layers, step by step. Security layers to prevent single point quantum vulnerabilities. Okay. Next, global quantum. So recent years happened, global quantum resale and regulatory frameworks. So what here it is, 2000 to 20 2016 to 2020 awareness phase, nothing but initial government advisors on quantum threats. So the what are the NSA, NCSC research funding initiatives for post quantum solutions. So these are the frameworks, regulatory frameworks. And next, up to 21 to 23, we have here standard development, nothing but standards developments, what they used to do. NIST finalized first PQC standard. EU Cyber Security Act incorporates quantum readiness. ISO IEC begins standardization work. Okay, next 2024 to 26 compliance requirements, compliance and requirements, regulatory mandates for critical infrastructure, quantum readiness, financial sector compliance, deadlines, defense contractor requirements. So they used to contractor requirements purpose they used to do in that year. Next 2027 to 2030, what they are going to do, widespread enforcement, nothing but global harmonization of quantum security standards, certification programs for quantum resistant products, consumer protection regulations. So these are the resilient regulatory frameworks. Next, so quantum secure internet vision. So future internet, nothing but we can say. So quantum, post quantum TLS, quantum safe routing, and hardened DNS with PQC. So we can call it as hardened DNS with PQC. So here one by one we can see post quantum TLS, nothing but quantum resistant transport layer, security protocols securing browser to server communications worldwide, and quantum safe routing, nothing but broader border gateway protocol BGP, secured against quantum attacks, ensuring trustworthy internet backbone routing. Next, hardened DNS, nothing but DNS SEC enhanced with post quantum algorithms to maintain domain name integrity against quantum threats. So quantum threats purpose, they are security internet vision they are developing, nothing but future internet. Next, so here are the critical infrastructure protection strategies. Protecting critical infrastructure requires a comprehensive approach. So what are the comprehensive approach? Asset inventory and cryptographicality, supply chain verification, nothing but supply chain checks, and legacy systems isolation, and continuous threat modeling, nothing but regular quantum threat modeling. So here asset inventory and prioritization, nothing but identify systems with longest life cycle and value, highest value, and cryptographicality implementation, nothing but build update mechanisms before they are needed. So they needed, they will build an update. Supply chain verification, ensure vendors have quantum resistant roadmaps. So they need to have roadmaps. Next, legacy system isolation, air gap or encapsulate system that cannot be updated. So legacy system isolation, what they used to do, air gap or encapsulate system that cannot be updated. And last one, nothing but regular quantum threat modeling. Okay, so continuously reassess as quantum capabilities evolve. So these are the protection strategies. So critical infrastructure, nothing but. Next, action plan, preparing your organization. So what they used to do, quantum risk assessments, inventory cryptographic assets like identify vulnerabilities and determine quantum threats exposure timeline for your specific organization purpose. And more, one more plan, develop quantum safe roadmap. So they used to develop quantum safe roadmap, like what is that? create a phased transition plan prioritizing high-risk systems, including test frameworks for post-quantum algorithms in your environment. Next, implement cryptographic agility. So cryptographic agility they are implementing in next plan. Modernize systems to support algorithm flexibility, enabling rapid updates as standards evolve and new threats emerge. So this what they used to implement and deploying nothing but hybrid solutions. What they are deploying? Hybrid solutions. Begin implementing or classical or post quantum systems for critical data protections while maintaining compatibility. So next last one is continuous adoption. So establish ongoing quantum threat intelligence monitoring and regular security posture reviews as the technology advances. Okay. And last one, key takeaways. Think about. So here, quantum threat is real and present. Organizations must act now against harvest now, decrypt later. So those attacks are targeting data with long-term value. Okay. Next, AI quantum convergence. Nothing but combining AI and quantum both creates both threats and solutions. So it will create both threats and solutions. The same technologies threatening current security and be harnessed to build more resilient defense systems. Okay. Next, post-quantum transition requires strategic plan. Nothing but developing crypto agility and implementing hybrid approaches will ensure resilience during the transition to quantum safe algorithms purpose. These are the steps. And next one, last one is cross-sector collaboration is essential. Okay. No organization can address quantum security challenges alone. For industry cooperation and public-private partnerships are critical. So this is the today's topic. Okay. So we have seen 4 agendas: quantum computing state of the art, quantum software ecosystem, and quantum convergence future implications. Okay. So here are the hardware and advancements. Hardware advancements, what are they? See here. Superconducting qubits, trapped ions, photon systems. Next, error correction. Error correction, nothing but so recent breakthroughs, nothing but EQC. Path to fault tolerance. Quantum systems are inherently fragile. Just now I have said. So with noisy and decoherence limiting computational fidelity. Quantum error correction is the critical pathway to scaling quantum systems. Nothing but recent breakthroughs. So what are the recent breakthroughs? First, demonstration of logical qubits outperforming physical qubits. Nothing but Google 2023. Error detection code implementation in trapped ion systems with 99.9%. So just now I have said measurement accuracy. They used to measure the accuracy. Okay. And last one, this scalability progress. Scale what they are used to implement, how they are scaling the challenge. So companies are using nothing but industries are using current systems for IBM, Google, IonQ operating the INSQ era. Nothing but 50 to 127 qubits. Okay. So laboratory prototypes are up to 1000 plus qubits. So here we can see IBM's Condor processor aims for 1121 qubits by end of 2023. So end of 2023. Next, 1 million plus, nothing but fault tolerant computing. Estimated physical qubits needed for practical quantum advantage in cryptographic and chemistry. So the gap between today's systems and fault tolerance. So this system and 1 million fault tolerant quantum computing represents both the industry's greatest challenge and opportunity. Bridging this gap requires advances in fabrication purpose or control electronics, cryogenics, and error correction purpose. This is the hardware scaling challenge. Okay. Next, quantum software ecosystem. So we have seen this also programming languages. So we use 4 programming languages, nothing but uh, so here is a programming language Kisbit, nothing by used by IBM. Q Sharp, Microsoft are using. Kirk, Google were using, and QASM. Okay, so these are the programming languages. So Kisbit, Python based framework, nothing but with the largest user community, provides circuit composition optimization and hardware access. Recent Qiskit runtime services allows containerized quantum classical hybrid execution purpose. These programming language used. Next, QSoft, QSharp Microsoft, used by Microsoft people. Domain specific language designed for quantum algorithm expression, integrated with Visual Studio and the quantum development kit. Features strong type systems and integration with classical code purpose. They used Visual Studio and the quantum development kit. Okay. Next, Kirk, used by Google. So they are using Python framework focused on NISQ algorithms and optimization, provides noise simulation and resource estimation purpose, enables access to Google's quantum processing purpose. So what it will do, enables access to Google's quantum processors. And last one, emerging, nothing but quantum assemble language standardization effort to enable cross-platform compatibility purpose. They use to these 4 technologies, nothing but programming languages, supports parametric circuits, classical control flow, and error correction primitives. So these are the software programming languages. Okay, next. And development tools and cloud accessibility. Just now we have seen development tools, what they are using. Yes, so development tools. So here are the bidirectional benefits. What are the benefits for you after using that programming languages? Okay, so AI quantum convergence, bidirectional benefits and emerging applications. So where they are emerging, nothing but in enhancing, nothing but computing, faster training, quantum neural network, combinational optimization purpose, these quantum computing enhancing AI. So applications, emerging applications are drug discovery, financial modeling, and climate modeling. So these are the applications, emerging applications of quantum AI convergence. Next. And next, future implications, industry transformations. Just now we have seen industry transforming from 2022, 2032 plus, I think, yeah, 20 here. Industry transformation 2023 to 2032, how they are transforming the timeline, industry transformation timeline. So early advantages, hybrid solutions, fault tolerance, transformation era. Nothing but we have seen that NISQ era. Yes. Next. So strategic considerations for organizations. So force deployment, development, experimentations, partnership, strategy, technology roadmap. So how they want to implement considerations, nothing but. Okay. And what are the takeaways? So here we can see quantum computing hardware is advancing rapidly across multiple technology approaches with error correction enabling the path to fault tolerance. The quantum software ecosystem is maturing with robust programming languages and cloud services democratizing access. AI and quantum computing are entering a symbiotic relationship, each accelerating the development of the other. Okay, organizations should develop quantum AI strategies now to prepare for industry transformation that will occur over the next decade. Organizations used to develop. Okay, cyber security implications require particular attention as quantum computing simultaneously creates new threats and defensive capabilities. Okay, next. Here we can see the convergence of AI, quantum computing and AI represents one of the most significant technological developments of our era, with the potential to solve humanity's most pressing challenges. These are the yes. Next, what we have seen, cyber security, nothing but AI, quantum and AI convergence, the future of cyber security purpose. Okay, exploring the revolutionary intersection of quantum computing and artificial intelligence, reshaping cyber security landscapes, threats and opportunity for technology leaders for future cyber security. Okay, next. So current state, we have seen current state is IBM using 433 qubit Osprey processor, Google's quantum supremacy demonstrations, D-Wave's specialized quantum handling systems, emerging modalities, superconducting trapped ion photonics. So these three are, we have seen first. These three are more hardware models and topological qubits. We are entering the noisy intermediate scale quantum era with practical applications emerging despite errors. So we are fault detecting the fault tolerance, error rates. So here superposition, entanglement, interference, nothing but quantum computing principles. These three are principles. Qubits exist in multiple states simultaneously, enabling parallel computation and exponential processing power for certain problems. Superposition. Next, entanglement. Quantum correlation between particles regardless of distance, creating interdependencies that enhance computational capabilities purpose. These principle. And last principle is interference. Manipulation of quantum probabilities to amplify correct answers and suppress incorrect ones, forming the basis of quantum algorithms. These principles are they are using quantum computing. So classical computing they used binary bits, but in quantum computing we are using qubits, right? Superposition of 0 and 1, right? Here they are used linear scaling. Here we are using exponential scaling potential, deterministic operations, probabilistic results, nothing but 36 99.9% is like that. So good for everyday computing tasks. Here Excel set specific complex problems. Here complex problems also we can find out using quantum computing. See here, quantum advantage emerges for specific problem classes, nothing but factorization. Just now we have seen Shor's algorithm. Yes, uh, factorization purpose, search mechanism, nothing but search purpose, Grover's algorithm, optimization, simulation, and machine learning tasks can be done by quantum computing. Okay, AI quantum convergence, a symbiotic relations. The fusion of quantum computing and artificial intelligence, creating a feedback loop where each technology enhances the other's capabilities. Quantum boost AI, nothing but boosting AI. Quantum algorithms accelerate training, enable more complex models, and solve optimization problems that limit classical AI. AI enhances quantum. AI optimizes quantum circuits, mitigates errors, and helps discover new quantum algorithms and materials. So these are the symbiotic relationship between AI quantum convergence, and QNNs, support vector machines, generative models, variational quantum algorithms. Just now we have seen quantum machine learning represents a new paradigm at intersection of quantum physics and AI. Okay, next, Shor's algorithm. Shor's algorithm represents the most significant quantum threat to correct cryptographic. So cryptographic purpose they used to implement this Shor's algorithm threat. Efficiently factorize large number. So factorization purpose. Just now we have seen Shor's algorithm here. Shor's algorithm purpose they use factorization purpose. Okay, efficiently factorize large numbers, breaking RSA encryption purpose. Okay, solves discrete logarithm problems. So used to solve discrete logarithm problems also, and compromising ECCs, and these threatens greater than 90% of current internet security protocols. Quantum computers will break much of today's encryption. The question is not if, but when. So is not if, but when. Quantum computers will break much today's encryption. Okay. Next, store now, decrypt later. Cryptographic crisis, supply chain vulnerabilities. Those are threat landscapes, quantum threat landscapes. So store now, decrypt later, nothing but adversaries are already harvesting encrypted data, anticipating future quantum decryption capabilities. These threatens data with long-term value. Next, cryptographic facility crisis. Many organizations lack the ability to rapidly update cryptographic systems, creating extended vulnerability windows as quantum threats materialize. And last one, supply chain vulnerabilities. Hardware and software dependencies create widespread exposure, as quantum vulnerabilities may exist in core components used across multiple systems. So these are the threat landscape. Okay. So what are the attacks? So powered attacks, nothing but harvest encrypted. These we have seen, right? Quantum decryption emerges, targeted decryption, credential and infrastructure breach. So those are, so the progression from current harvest now. So we have seen all these security solutions. What are AI quantum security solutions? Real-time anomaly detection, advanced analysis, adaptive security, posture. So these are the things we have seen already. Okay. Next, QKD. It is one of the important. QKD, quantum key distribution, represents a fundamental new approach to secure communications. So QKD represents a fundamental new approach to secure communications. Uses quantum properties to secure key exchange purpose they used to do. Next, detects eavesdropping attempts through quantum observation effects. So detects the eavesdropping attempts and provides information theoretic security rather than computational security. So what it is providing? Information theoretic security rather than computational security. Already being deployed in critical infrastructure and financial networks. So already being deployed. Okay. Recent advances, satellite-based QKD demonstrations, integrated photonic implementations, and metropolitan QKD networks. So these are the key distributions. Okay. Next one, sectoral impact analysis. So these are the sectors analyzing purpose they used to do. Financial services. What are the financial services? Healthcare, defense. So these are the analysis purpose we used to. And post-quantum cryptographic algorithms. So there are different algorithms, Shor's algorithm and post-cryptographic algorithm. Okay, here NIST's post-quantum cryptographic standardization process establishing new quantum resistant algorithms based on mathematical problems that remain hard for quantum computers. So lattice-based cryptography. So based on the difficulty of finding the shortest vector in a high-dimensional lattice, Crystal Kyber selected as primary key encapsulation mechanism. So what they used to do, Crystal Kyber selected as primary key encapsulation mechanism. Next, hash-based signatures relies on the security of cryptographic hash functions. Symfonics provides stateless signatures with minimal assumptions. Okay, and multivariate cryptography, security based on the difficulty of solving systems of multivariate polynomial equations. So these are the post-quantum cryptographic algorithms standardizations. Okay, next. Hybrid security models, composite cryptography, AI enhanced modeling, hardware software integration, defense in depth strategies. So these are the security models we have gone through. Global quantum resilient regulatory frameworks, awareness phase, standards development, compliance requirements, widespread enforcement. So these are the resilient regulatory frameworks. So secure internet vision purpose quantum. Post quantum TLS, nothing but quantum resistant transport layer security protocol securing browser to server communication worldwide. So these post quantum used to worldwide. Worldwide they are uh, protocols, securing protocols browser to server. Okay, next quantum safe road routing. I think about border gateway protocol BGP secured against quantum attacks, ensuring trustworthy internet backbone routing. Okay, next hardened DNS SEC enhanced with post quantum algorithm to maintain domain name integrity against quantum threats. Okay. Next, critical infrastructure protection strategy. So, what are the strategies we have seen all this? So, what are those? Once again, we will see asset inventory and prioritization, cryptographic agility implementation, supply chain verification, legacy system isolation, regular quantum threat modeling. So, these are the comprehensive approach for protecting critical infrastructure. Mhm. So asset inventory and prioritization means identify systems with longest life cycle and highest value. Cryptographic implementation, nothing but build update mechanisms before they are needed. And supply chain verification, nothing but ensure vendors have quantum resistant roadmaps. And legacy system isolation, air gap or encapsulate systems that cannot be updated. And regular quantum threat modeling, nothing but continuously reassess as quantum capabilities evolve. Action plan, what are the action plan? Preparing your organization, nothing but organizations what they used to quantum risk assessment, develop quantum safe roadmap, implement crypto agility, deploy hybrid solutions, and continuous adoption. Okay, and takeaways. The quantum threat is real and present. Yes, organization must act now against harvest now, decrypt later. Nothing but attacks targeting data with long-term value. AI quantum convergence creates both threats and solutions. The same technology threatening current security and be harnessed to build more resilient defense system. And one more, post-quantum transition requires strategic planning. Nothing but developing crypto agility and implementing hybrid approaches will ensure resilience during the transition to quantum safe algorithms. And last one is cross-sector collaboration is essential. Nothing but no organization can address quantum security challenges alone. For industry cooperation and public-private partnerships are critical. Yeah, so this is what we used to cover all the areas of quantum computing and AI convergence. Okay. Yes. Is there any doubts? Hello.
Hello,
Yeah.
sir. Yes,
Yeah.
participants, if you have any queries, you can unmute yourself and ask the doubts to the expert. Sir, I think no doubts, sir. You carry on.
Yeah. Yeah. My part is completed. Actually.
Okay.
Okay. This is our agenda. Today's agenda.
Okay. Thank you very much, sir.
Okay.
Your session was very interesting, very
Okay.
straightforward, and provided very good information, sir.
Okay. Thank you.
Thank you very much, sir.
Thank you for your patience and time. Thank you.
It's our pleasure, sir. Thank you very much. All the participants, uh, feedback link for second session will be available in chat box. Please submit that. Arun sir.
Sir, Arun sir not there. What do you want? Siraj sir.
Yes, sir. Chandramouli sir. Listening, sir. Arun sir తోనే మాట్లాడుతున్నా.
Okay, okay. No problem, sir. Better give a break for 10 to 20 minutes. Sir.
Yes, yes. I am also thinking the same. Dear participants, we will have a break for 15 minutes. Don't leave the session. Please be connected. We will join after 15 minutes. And please submit feedback link for second session, which is available in chat box. I will also post it in our WhatsApp group. Don't forget to submit it. Thank you. We will have a break for 15 minutes. Good evening, one and all. Is I audible? Please, anybody can give response. Is I audible?
Yes, sir. Audible, sir.
Thank you very much, ma'am. Good evening, one and all. I welcome all the participants to the last session of 6 days online faculty development program. I hope our team of experts are giving insights to enrich your knowledge in the domain of quantum computing and its security. Now, I will take privilege to invite our speaker one more time, Dr. Kishore Kumar Gajula, is distinguished academician, researcher, and technologist with 18 years of combined experience in academia, research, and IT industry. He holds a PhD in computer science and engineering, and he currently registered postdoctoral research, presently serving as head of research and development at News and Infotech, Hyderabad. He specializes in cloud computing, blockchain, artificial intelligence, and machine learning. He has authored more than 45 research papers, 4 books, and 3 patents, and has conducted and organized several international and national conferences, FDPs, and workshops. He is recipient of prestigious awards, including the Young Researcher Award 2023. Dr. Kishore actively contributed as a PhD guide, keynote speaker, and editorial board member of multiple international journals. I would like to invite Dr. Kishore Kumar sir. Sir, welcome you, sir. Over to you, Kishore sir.
Yeah, thank you, sir. Thanks for inviting me. Good evening, all of you. I think today is the last session for the entire FDP program in our college. So today's session is a completely just overview to the complete safe mechanism in machine learning and one more real-time examples. Nothing but a real-time capstone approach is how we can working with a real-time quantum applications. So we will look into that completely real-time applications. I think if anyone is opening with a Google from the laptop, you can open the Google Colab. I think most of the people know about the Google Colab for using of running of a Python programming. Today's session we are working with a quantum, IBM quantum techniques. So we can work with an IBM quantum techniques. I will show the example how it will be work with an quantum random techniques and how it will be generated random numbers to one or one to manys. So how it will be encrypt and how it will be decrypt the key. And if there is any key mismatch will be there, how the algorithm will be alert to the user. I will show it in the real-time example. So before that, one more small topic will be there for us. Just it's 5 to 10 minutes of time. That's it enough. So over I'll share a screen. This is a small topic, quantum safe machine learning securing it in the post-quantum era. So here, how the quantum computing is securing the machine learning models. So that is the main and small concept in the last final session. So here, what is the quantum computing fundamentals? Almost all fundamentals all completed. This is the fundamentals of one more time. We need to recap how it will be work. So in the fundamentals of quantum mechanism cryptography, first is a superposition method. It is an 1-0 or 0-1 and 0-1 or 0-1. That is the superpositioning. And entanglement, that is a pavement of a qubit methods. And then neo-cleaning theorem is nothing but quantum states cannot be copied of any other detection techniques. And quantum uncertainty, measuring of one property affecting with another property sets. Right. So this is the QKD. I think so most of the sessions in the quantum cryptography So quantum techniques, all of the sessions that QKD, I think all 13 sessions QKD will be common, right? So I think much more known about this. So physical layout, security, and reverse dropping detection and future proof of keys. So quantum computing, that is the classic computing, and then quantum computing. So classic is an 0 or 1, and the quantum is an 0 and 1 method. So operations are limited to the in classic computing and quantum computing. So in this session, we are going to work with a quantum computing, that's computing with work with an IBM quantum computing, right? So we can run the IBM quantum computing program in Google Colab, right? So it's a hands-on session. The entire session, this session is only the hands-on session, right? So quantum building blocks, that is a gates and circuits. So quantum gates are the main gates we are using in the quantum, that is an AND or NOR gates, right? So quantum circuits are initialization of stages. At the stage initialization will be a 0 and applying to the all the gates at in a sequential order. So quantums can be generated in a qubit method. The qubits are all states included in the sequential order set. So it will be work within a proper output. Right? So in that the complete quantum algorithms, the base and the strongest algorithms are these two algorithms, Grover's algorithm and then Shor's algorithm. So actually I'm trying to work with the Grover's algorithm or Shor's algorithm, but it's not possible to work with a direct with using a Google Colab. That's the reason we are not working with this Grover's algorithm and Shor's algorithm. So in that Grover's algorithm and Shor's algorithm can work within a particularly deployment of an IBM cloud or else any Pike clouds, external quantum clouds based only, it will be work. It doesn't support to the Google platform. So it's not showing in a proper output. Just it will be showing up an algorithm structure and it will be allocated within a Google methods. Right. So, and then simulation will be there. We can access within a Google simulations or else Google simulators. We can generate a cloud-based map plotting information. So there is a base quantum thread to machine learning. So what are the main threats to the machine learning? How we can overcome with the quantum computing, right? So public key encryption token is the main threat in the machine learning subject. So how we can overcome means that is a public key encryption. It's a general topic. So with using of an RS algorithm should be used for the qubit method accelerating to a particular attacking models, right? So this is a simple concept of an quantum computing, that is an harvest now and decrypt later. We can encode and it will be accessible information at later, right? So this is the future development of an implementation of a quantum threading methods. So now we are into the stage of 2025 to 27. It's an accessing with an 2084 bit RS algorithm. That is nothing but 2 MB RS algorithm bit encryptions, right? So it's an working with an PQC, is nothing but post quantum computing techniques for critical systems. So it will be working with an completely in our research area. After 2030, it will be going to execute in the real-time scenario of a quantum, right? So with using of a post quantum, how we can store and how we can access. That is in the same lattice method, hash method, code based and multivariates, right? So here we can check with a real-time application. Yes, this is one of the best example, right? So now we can work with a Google Colab. So from who are working with a laptops or desktop or mobile phones also, just open the Google Colab once. So others, I think participants, please respond for this session. For hands-on session, easy to access. So for any kind of algorithm, first we can work with a step-based. So I will explain the process of steps. So you can directly work with a directly information set, right? So let's open your screen, and I will type it the same in the notepad also, right? Yes, all of you open the Google Colab in your laptop or mobile phone. Also, mobile phone also it will be work. Just open the Google Colab and log in with your mail ID into the Google Colab. So first step in any kind of online Google Colab or online platforms, we need to install the libraries, right? So I am saying that is a we are working with a quantum. Our main motto of the project main motto is quantum random number generation. This is our main motto. Right. So what are the prerequisites for this means we need to install the libraries. So first we can install few libraries, and next we can work with a libraries. So what are the install libraries will be there? So we can work with a libraries. So how we can install the libraries in the uh, Google Colab? So simply first we can go with an pip install So that is a QIS kit. It's nothing but this is an QIS means. So here quantum information science kit. It's an open source library for an IBM quantum computing, right? So it's an open source library for quantum computing framework for IBM working structure. So whenever we want to access of an IBM properties, IBM quantum computing properties into the Google Colab properties, access with a running with a Google Colab, this library is a mandatory to install. So it's an access with a Google Colab, right? So that is a pip install US kit, right? So, and then we need to install one more library that is within this QIS kit item AR 5 crypto do. It's nothing but this is the library for accessing and conforming within a working with. That is the pip install QIS kit script AR. AR means that is a completely air. That is a simulation method. That is access for an this library is access for an AR means air. And PyCrypto. It is a Python cryptographical library. That is a PyCrypto. That is a PyCrypto. That is a Python cryptographic library. So we need to install here. That is a pip install QS kit. This is the access with an IBM library for allocation to the Google Colab. Next, QS kit AER. This is the sub library from the QS kit. It will be installation of an AIR library. That is a simulation library. So it will be accessed within a simulate within the local system. Local, we need to, whenever we want to run within a local system, AER is the mandatory library. And next, PyCryptodome is the, that is a Python cryptographic library. We need to install. Okay? So check it, how we can install. Just simply copy and go within a Google Colab and open a new notepad. So here you can type that console, type the library name and run. So mandatory to install the library. Management solution. That's what. Sorry. I Right. So it's an installing of all the libraries. So now all the libraries are installed. So this is an initialization of a library. Only one base library. This is an action with an IBM quantum cryptography and IBM air simulation model and Python cryptography. So it will be work with an Python cryptographic library. Right. So we are install all these three, and next from these libraries we are importing of an what are the required libraries for this quantum random number generation. Right. So from we are importing is the QI skit, not QU. QI skit import quantum circuit and transfer. Right. So we are going to import from operations. We need to install all these libraries. So we can try all the libraries at a single time and we need to publish. That's it. From UI skit underscore AR import AER. It's nothing but we are accessing upon a simulation method from the import AER. Directly it will be accessed with an AER. Next we are accessed with an crypto. Right. So from crypto, we need to what first we can access, that is a cybertext we are going to access. And next, what are the algorithm we are going to use here? That is the AES algorithm. Take an example and work with an AES algorithm. And next, we can install with libraries. So that is how it will be work is nothing but this is a hash library. So any kind of quantum cryptography, hash library is the mandatory, right? So whenever we want to show the simulation result, it is a matplot libraries. Nothing but this is a basic Python library. SPL. Right. So we are going to install all these in this. Right. Right. It's imported. Matplot library. Directly it will be work with all the structure sets. quantum script, quantum circuit and transfer. Right. So all the resources, all the requirements are satisfied here. So all the libraries are installed. Something that we are installed as a library, and we are importing of a library is also finished. So here the completely 9 steps will be there. From the 9 steps, we are finished of 2 steps. Right. So anyone is showing? Please respond. Yes. Yes, from the 67 members, anyone is doing a practice
Yes, sir.
session?
It is visible, but it is showing a dialog box, sir.
What is the error it is showing now?
You are presenting, to show my screen anyway or stop presenting. The dialog box is displayed.
Okay, I will stop this presenting. You can share. Yes, I am shared all the libraries information in the chartboard. Each of the libraries. Google Colab. Right. So this is the first step, and then step 2. There is an importing of the libraries. Yes.
సరే అమ్మా.
Screen share was not done, sir.
Yes, I will share the screen again and check it. This is a main program aim. What is our project aim? That is a quantum random number generation. Right. So this is the first import file of an installation of libraries, and these are the libraries we are going to import of an install libraries of a particular Google Colab file. Right. So after that installation of an libraries, we are going to design a quantum random number generation. So we are going to design a quantum random number generation, which is in a quantum circuit. First, we need to design a circuit of a quantum. Right. So here we are going to use quantum circuit of, it's a choice of your wish, that is an 8 into 8 or 16 into 16 or 32 into 32, that is your wish, 62 or 24, whatever it may be the way. So I am designing a circuit size is an 8, right? So we can work with an range of an information set, that is an quantum range is an 8.
Excellent.
Yes, this is a range of an qubits into the superposition. This is a H range is a superposition. I think most of the people here, this is an in our quantum computing, there is a range of a superposition method. Superposition method that is mean by this is a quantum circuit of an H range is that is a superposition range. Right. So next we can measuring of a quantum circuit measure range, that is a measure of a range of 8. Sir, why we are choosing of a range of 8 in 2 times means, so it is a circuit designing of an 8 into 8. That's the reason we are going to choose of a measurement of a range of 8 into 8. So this is a creation of a quantum circuit. So this is a libraries installation. This is the importing of an information. Next, quantum circuit. This is a generation of a quantum circuit. Quantum circuit generation also completed. So next we are going to generate of an QSKit AER simulator. We need to run this AER. So how we can run the AER simulator? It's nothing but we can start with a simulator. Right? That is a simulator of an AER dot get backend of back. We need to work with a simulator in the backend. That is the reason we are going to use the AER backend and run the simulator in the backend process. Right. So it's a working of a simulator. So next we need to work with a compile. So we need to compile. Next, that is a transfer of QC simulator. Right. Right. So next we need to store the simulator. It's nothing but first enabling the simulator, next compile the simulator in the backend, and next store the simulator result. Right. Simulator dot run is nothing but whenever we are running of a program, it will be work with a compile. Right. And here it will be showing up a shorts equal to, that is the size of the qubit information data set. Is nothing but n number of times repeated. I am giving up a size is 1000. That is, it will be showing up a print result of 1000 times. It will be repeat the value. Right. So this is the QSKit AER simulator running. It's nothing but here we are running of a simulator method. Right. So next we are going to step 5. So our main aim is random number generation, right? So we need to generate of an extract the random results. So here we are taking of an quantum circuit size is the 8 into 8, and it will be working with an 8 into 8. It will be work starts with an 1000 recorded shots. It's nothing but after 1000 it will be generated, right? So extract we need to extract the result from the random, right? So here we can extract with an accounts result dot get underscore counts. Right. So next we can direct print
Then why you are saying like that?
Sorry, ma'am. What happened? Yes, anyone respond?
Yes, participants, unmute yourself and answer the question.
Yes, it's not like in a remaining all the 12 sessions. You need to interact with me to finish of an task. And this is a capstone project. Is nothing but we need to mandatory to upload what are the project name we are finished into the FDP portal. It's mandatory session and mandatory to work with your Google Colab. In the schedule also, it will be showing that capstone project. Right. So please respond the voice. Right. I will type and I will explain the complete concept. And last, finally, you can directly copy and paste the same into the your Google Column. I will share in the chat box. Right. So we are going to store the results of an extraction of a random results. So how we can extract means that is a printing of a quantum measurement outcomes from counts. The count size will be here. That is a count is an 1,000 shots. It will be generating of 1,000 shots. Right. So in that same, we need to pick up of a random generation. That is a bit string. So our main aim is a generation of a random string. So we need to generate of a bit string. That is a random. You can generate of a random underscore bits equal list of counts dot is and then addressing of a 0. It's nothing but initially it will be starts from the randomization number and address node will be stored in the 0. That is a print string. We need to write a print. So we can start with a new line. 1 random bit string. This is a random bit string we are going to generate. This is a random bits. Right. So here that is a step 5 is also completed. Extraction of a random results. Nothing but first we can store into the counts, getting of a random results count. It will be store the random counts and picking of a random bits information. It will be stored. So next we need to work with an algorithm, right? So here we are importing of an AES algorithm. So next we can write the code for algorithmic structure, right? So here step 6, this is a step 6, that is a key bytes information. Key bytes equal to integer of. So what we are accessing, that is a random bits. Here this is a random bits we are going to access. Random bits and that is a 2 to conversion into the bytes. That is in a length of random bits. So by default, random size of bytes information is a completely random. That is an 8. So it will be accessed with an 8, and this is a big method. Right. So here the key assigning of an AES algorithm. So AES algorithm can be stored into the byte encryption data. Right. So here that is an AES key. So after a generation of an algorithm, we need to generate a key for the information set. So where we can store the key in the quantum simulators means. So here every key will be stored in the hash library sets. Right. So we can AES key can be stored into the hash library. The hash library will be converted into the SHA-256. So I think all of you people know about the SHA-1 algorithm, right? For the encryption standard method. So it will be encoding of a byte information into the bits. So that's an information will be converting of a data into the encoded exact information sets. Is nothing but it will be generated of an information method, right? So that is a hash value indexing is in a library with using of an AES key. So we need to print, we need to check the key is generated or not. Is nothing but we can give the print statement. We will check the quantum AES key, right? quantum AES key. In that is in the form of hash value. It's nothing but hexagonal value or else hash value of a particular index pack. Right. So we can give that is an AES underscore key dot hex value. Nothing but it will be derived from the hexagon. Right. So this is a printing of an converting of a random key into the bytes of AES. Right. So we are converting of a generation into the AES. So next we need to write only the two more steps. Encryption is the one step and decryption is the one step, and generation of a graph, that is also one step. That's a simple. Right. So here we can encrypt one message first. That is the model will be generated. We are going to encrypt a message. Right. So what is the message? The quantum based random number generation at ATAL FDP. For example, this is my text, right? So I want to give this text as a message. So now we are converting this message into the ciphertext. So how it will be work within a ciphertext means AES, right? So cipher equals AES dot new creation of an object for an AES key. Right. So here that is an AX mode is an extension. Right. Right. So this is an cipher means it will be stored the encrypted tag information. That is a cipher dot. Right. So we need to store the ciphertext information. Ciphertext from a tag. We need to store the information into the cipher dot encrypt underscore and underscore digest of message. Right. So here this is a text will be encrypted. Right. So whenever you want to print the encrypted text, just simply give the print statement of an encrypted tag. So when it is in the new line, there is an encrypted ciphertext. It's not an original text, it's an ciphertext in the form of text. That is one ciphertext. Text. All right. So here this is the step for encryption. So next we need to decrypt the whatever the text we are encrypted, we can decrypt from the same message, right? So here we can run the same this process into the reverse order. So first we need to decrypt of a method, that is a cipher decrypt. So where we can decrypt is nothing but with using of an AES algorithm and AES key. We are going to decrypt. So what mode we are used here? Same. We need to take this step, right? Cipher decrypt of an AES mode and AES underscore key. And we need to add one more here. That is an N1. Right. So here we can store the decrypted text into the decrypted. Right. So here that is a cipher decrypt dot decrypt, and it will be going to verify the ciphertext. It's nothing but it will be going to verify the original ciphertext also. So if the key will be changed, it will be alert the message text and tab. Right. So here it will be verifying and decrypting the text. Right. So next we need to print the value. Print decrypted message. So what is the decrypted message here? Decrypt dot decrypted dot. So in that concept, encoded method. So here we can write the decode. Right. So here this is a decode. Right. So next, plotting of an histogram technique is nothing but that is an for random generation. Just it is an showing of a graphical. For graphical analysis, we are using of a library of an import matplot libraries. Right. So that is a plot using nothing but PLT. We are declared in the above. PLT dot figure. So here we can give that figure size, fixed size. I'm giving the fixed size is 10 and then 6. And next plot dot. So you can give any type of chart. I'm given the bar chart. In the bar chart, it will be counts dot is and counts dot var. Right. Plot dot x6 rotation equal to over 90. So it's nothing but that is a plot diagram can be displayed of net 90. And next the plot title, we need to give any kind of title. Plotting of a title, that is a quantum random, right? Random number distribution. So it's an we are taking of 1,000 shots. That is 1,000 shots. Nothing but input value is given of 1,000 shots. Right. So next we need to print this. That is a flat dot show. Right. So this is the code we are going to be execute. Yes, all of you following. Anyone can respond. Hello. Yes, please, anyone can respond. I hope you people are understood or not understood. Yes, sir. Very good response, sir. Yes, I will share the code. So I think all of you install these libraries, right? Yeah, I will share the code. Yes, libraries are installed, then I will share the complete code. Yes, and share the complete code. You can type and paste the same code into your Google Colab. Yes, sir. I will share and show me the code also. I will take that code and copy the complete text. Paste it here. Right. I will work with a little bit slower. Compared to the your Python programming, it will be work with a slowly. Yes. Just check it. Here, this is an our output. So check here one random bit string that is an 1010 and this is the AES key for an access method. And here that is an encoded method that is in a quantum random keys. And so here it will be work with a quantum distribution methods. So it will be showing up in a graphing period. So here it will be outcome of it will be showing the number of outcomes also. Here you can check it. These are the list of 1000 outcomes. So I am generated with an 1000 outcomes. So it will be showing up in 1000 outcomes. It will be accessed with 1000 outcomes with an graphical analysis. So this is 1000 shots. For example, you want to give it 100, you can that will be limited to the 100 shots. So is it clear? Yes. Dear participants, please respond. If you are response only, I will share the answers. Otherwise, I can show it here itself only. One more project will be there. Right, at least respond in the chat board also, no problem. Yes, anyone executed the code? Yes. Yes, girls. Yes, sir. Is it completed? The output will be showing like this. Anyone, please share the screen. I will take a nice screenshot. Or else, respond at least. Yeah, anyone can unmute and you can discuss with me. No problem. Yes, sir. You are executing or else start the program. Please unmute and respond.
Anybody from participants, please unmute yourself and respond.
Yes, sir.
Yes, Santosh sir. Tell me, sir. Yes, it's mandatory to do the application, right? Yes, this output will get after running of this program. It will be directly generated of a quantum method. So if you want to decrypt of a size will be decrypted into the less. You want to give it an less code. Directly you can give it an shorts into the 500. Right. So it will be directly displaying up an shorts into the 500. It will be good. Just for the first time installation, it will be work within a slower one. Right. After that, it will be directly access within a first of an course. Right. So this is an encoded method of an quantum based. Is an actually this process can work with only the IBM machines, but with using of an QS-Kit encryption algorithm, sorry, QS-Kit libraries. So we are accessing of an QS-Kit into the Google Colab Python libraries. Any kind of Python libraries, we are working with the C. Yes. Yes, sir. One person is generated. Yes, sir. Satish Kumar, sir. Yes. Exactly, sir. I got it. Yeah. Please send the code 1 second. Just wait. This is the code. Exactly, sir. Nice. You have generated the code. And you can check the in that libraries information also. It's a completely information of an completely the output value will be different. So it is not like in a similar data. It's in a completely differential data. Right. So whenever it's an quantum bit, random bit string, this is an 1011 or 410, that is an a random bit. One random bit string pick up from this complete entire 500. Right. So it will be pick up of an only one string, right? So we are encoded, that is an hexagonal of an AES method and encryption code. Whenever we can decrypt with an decrypt directly with a message directly, that is a quantum random method. So this is a simple example of a quantum working process, right? So this is only for the text based, right? So next another program we have, that is an image based encryption and image based decryption. So we want to encrypt and want to decrypt of any image. So I think so most of the people know about that image encryption and decryption techniques, right? So we can encrypt of a plain image, and we are going to encrypt is nothing but the image can be blurred or else block boxes will be generated on that image, and next directly it will be an decryption of an image. So for this kind of we are using only the flattened information sets. Directly we can upload with a randomized information set. So for generation of a random information, so directly we can access with an code. I will share the code directly. Why? Because exactly is the ending time for today's session. Just right, I will share the code and I will explain. It's not possible to type the code and explanation. Directly I will explain the code with using of a libraries. Right. I will explain everything in the particular code. Yes, this is another code. So all of you just check the code. I will explain the process once again regarding this code. So this is the same libraries. So what are the library we are going to install? That is the QS kit. That's a quantum cryptography technique from the IBM library, right? So quantum information science kit, that is an IBM library, and we have from this library we are going to use with an pill. Is nothing but pillow. So pillow library is an imaging library. So imaging library is nothing but it's an allocation of an images. We are working whenever we want to work with an images in the cubic. So we can directly access with an pillow map. Right. So that is a VI. We are importing of a quantum circuit like in a same. From that we are accessing of a PIL import image. So it's a mandatory. So why? Because we are encode and decode of an image, right? Next, import numpy as an NP. That is a numerical pattern. I think most of the people know about this numpy, right? So here we can generate of an downloading of an any one random image. I am taking of an elephant image, that is an strip S uploads Wikimedia URLs African blush L. So directly it will be downloaded from the Wikimedia portal and it will be store the image into the elephant.jpg. And next it will be going to generate a small quantum random. So that is a resizing of an image into the original color image. That is a resize. It's nothing but reduce the, simply it is an crop the image into the 128 into 128 bit size image. So here this is the image size also resize. This is a step 2, right? Or this is the first step 1, downloading of an image. Step 2, that is a resizing of an image into the 128 into 128. Next, step 3. So what is the step 3 here? That is we are going to generate a small quantum random number 6. That is here I am taking the random number size 16, right? Same simply quantum random number And simulator can be worked with a backend simulator, that is a quantum circuit n bits, and the h range is the n bits, is nothing but n number of bits, that is up to 16. The bit size is 16. Automatically compile, and compile can store into the transpile, result into the compile, that is a simulator, that is a directly displaying of a random seed value. Right. So seed value here, it will be control random seed, and it will be quantum generated seed generator. Right. So here next, it is we are using of uploading of generate small quantum number seed, that is 16 bits. Right. 16 bits equal qubits equal 1. So why? Because we are choosing of 16 bits, sir. So is nothing but 16 qubits equal to one number in the quantum cryptography. 16 qubits into one number, right? Just keep in your mind. So 16 qubits equal one number, right? So here that is a seed value. So seed value we can directly access, and next expanding of a quantum into the full random key using numpy. There is a random key. NP means numpy. So orange random number generation of a random default of a given input. That is 256 to decrypt of a unit. So next we can encrypt. Encrypt is nothing but XOR algorithm, that is plotting of an array flatten method. So array of a bitwise XOR, that is XOR is an encrypted, right? So that is plotting of a key and encrypted image. It will be reshaped the arranged of an encrypted image. Is nothing but it will be display of one kind of image of an original image. Next, it will be going to encrypt the image. After that encryption, we are displaying of an encrypted image. Right. Next, we decrypt the image. So we are going to XOR. Right. Again, we can work with a same key. Right. Decrypt the image and decrypt of a reshape the value. And next, showing of an original image, encrypted image, decrypted image, size. Right. So it is a big axis, that is a plot, subplots of an 1, 2, 3. And big size is 12 into 4. Right. So first it will be showing that axis of an 0, image show area of array of set title of an original elephant, and axis is an of image of an encrypted image, encrypted noise, and decrypted method, and decrypt the noise, and it will be showing the plotting of a shown method. So just check this working method. I can go with a code here itself only directly, but it will be work slowly. Why? Because it will be directly download the image from the internet, right? And then it will be process the same image. Quantum seed, just check it here. The quantum seed is generated, that is a 16. 378 seeds will be generated. And this is the original image. This is the encrypted noise image. This is the decrypted elephant. So encrypted image, the decrypted image is matched. And this is the encrypted image with using of a quantum based encryption method. Yes, if you want to check it, you can run in your program with another Google Colab. The second program also working. Yes, anyone can execute the second one. Compile. Anyone? Yes, sir. Please respond. More 10 minutes time to us. I think you people are getting the board from a continuous sessions from the 2 o'clock to 6 o'clock, right? Or else you people are muted and simply putting your mobile into the bags. How we can believe? Yes, sir. Anyone? Around 60 participants will be there here, right? Only, I think so, only 6 members are worked. Yes, Satish sir, working as expected, execute the code. Yes, thank you, sir. It will be working, definitely. I think you people getting so much knowledge on that, how to work with a quantum based with using of an IBM cloud or else IBM quantum techniques. So whenever you only the sir, why you are only preferred that IBM Quantum means Google Colab easily supports the IBM Quantum techniques. That's the reason I am taking the two examples in the IBM Quantum. Right? So remaining quantums will be also there working, but it will be getting often a failure ratio will be very high. It's not integration method. Directly, it's not integrating within a Google, right? Or else open source platforms. Directly, you need to go within a Linux command. So you need to work and you need to execute the methods in another file. So that is the reason we are working with only the IBM quantum technology, right? That is the main intention to choosing of an IBM quantum algorithms for your caption code, right? So here we are encrypted one message, text message, and here we are encrypted one image and decrypted the same image also, right? So clear? Yes, from anyone, please respond. Clear. Okay, sir. Remaining. Yes, I think if you people are busy, then you can directly practice this code at in Google Colab later also, no problem. I will share the complete code to coordinator sir or Sirajuddin sir. I will share completely. So directly you can exit the same code. It will be work. And here this is an Wikipedia uploaded image. If you have any more doubt, you can check this image also. Elephant image will be work. It's an URL of an elephant. Right. So I am taking the example is the elephant. If you want to take any kind of image, you can directly go with any kind of image. Just simply you can add the information of an URL. Same URL information you need to add here. Right? That's it. Right. Okay. I think all of you people are understood about this session. Any more doubts regarding the session, regarding this project concept? Please ask me. Feel free to interact with me to the end of this session also. Anyway, I will share and I will explain any kind of queries from any participant. Thank you so much, Satish sir. Yes, shall I give the quiz or else directly you can write the exam? At 6:30 p.m. you have an exam, right? Shall I give a quiz in this session? Or else directly you can write the exam. Please respond at least that one also.
Kishore sir, they want to write the exam directly.
Yeah, okay, sir, fine. No
Better you have to give a break for 5 to 10 minutes.
Yeah, sure, sir. I will manage this. Yes, thank you all of you. Thanks for giving an opportunity. So once again, thanks to our college management and principal sir and coordinators Chandramouli sir and co-coordinator Sirajuddin sir for giving us a wonderful support from the first session is my session and the ending of the session is also my session. Thank you so much, sir. Thank you all of you for adding up a great session with you people. Thank you so much. Thank you all of you.
Thank you very much, sir. Thank you very much. All the participants, we will have a small break and take care about the exam. Details of exams are there in our WhatsApp group. Please go through that.
Dear participants, the online exam will commence at 6:30 p.m. sharp and will close at 7:15 p.m. We kindly advise you to log into the portal at least 10 minutes early and ensure that your internet connection is stable throughout the exam. Please log into the portal and take the exam. All the best for your exam. Please leave this session.
అయిపోయింది క్లాస్.
all the participants are requested to log out from this meeting, log into your ATAL portal, attempt the exam. Once exam is completed, please re-log into this session at 7:30 p.m. Repeating one more time, all the participants are requested to leave the session, attempt the examination in ATAL portal. Once your examination is over, submit it. Then again 7:30, come back for valedictory session. Thank you very much. And all the best for your exam.
Sharda madam.
Yes, sir. Yes, sir.
Madam, please start the session.
ఒక్క నిమిషం వినోద్ సార్ ఉన్నాడా? ఒక్క నిమిషం వినోద్ సార్ ఉన్నాడా?
Yes, sir. Sir. Wait, sir.
ఉన్నాడా?
ఇంతకుముందు వచ్చారు సార్.
ఒక్క నిమిషం మాట్లాడతాను సార్తో. 1 minute.
సరే సార్. Sharda madam.
Sir.
Madam, please start the session.
Yes, sir. Good evening, everyone. It gives me immense pleasure to welcome you all to the valedictory session of the online FDP. I, Sharda, on behalf of CSC department. Pleasant good evening to our respected dignitaries, General Secretary of Sri Vageshwari Educational Society, Dr. G. Srinivas Reddy Garu, Joint Secretary of Sri Vageshwari Educational Society, Dr. D. Srinivas Reddy Garu, Honorable Member of Sri Vageshwari Educational Society, Sri Vishwanath Vinod Garu, Honorable Member of Sri Vageshwari Educational Society, C.H. Prakash Reddy Garu, Dr. C.H. Srinivas Garu, Principal of Bageshwari College of Engineering, HOD and Coordinator Dr. N. Chandramouli Garu, Co-Coordinator Dr. M.D. Sirajuddin Garu, Eminent Resource Person Dr. G. Kishore Garu, distinguished faculty members, enthusiastic participants joining us from various places. I, Sharada, on behalf of CSC Department of Bageshwari College of Engineering, welcome you all for this valedictory session of the AICTE ATAL sponsored FDP on quantum cryptography and its impact on cybersecurity in the digital age. Over the past 6 days, we have witnessed enriching sessions, valuable discussions, and meaningful exchange of information and knowledge, which have truly made this program is a memorable learning experience. This FDP future comprehensive sessions covering both fundamentals and advanced topics of quantum cryptography and cybersecurity. Some of major areas discussed included basic of quantum mechanisms for cryptography, quantum key distribution protocols such as BB84 and E91, applications of quantum cryptography in secure communication, current cybersecurity challenges and how the quantum technology address them, future trends, quantum resistant cryptographic algorithms and post-quantum security. Each resource person brought in-depth knowledge and real-world perspective, making the session highly impact. Thank you, sir. Now I would like to invite our resource person, Dr. G. Kishore, sir, to address this valedictory session. Yeah, of course, sir may be disconnected. Now I am delighted to invite our respected coordinator, sir, to share few words about valedictory session. Welcome, sir.
Before that, you ask from the participants.
Sir. Yes, if those who have finally I thank management also. If anybody participants, if you want to share your views, you can share.
Sir, good evening, sir. This is Dr. A. Karthik from Institute of Aeronautical Engineering, Hyderabad, sir. First of all, I congratulate to the coordinator, Dr. N. Chandramouli, sir, and also co-coordinator to the Mr. Siraj, sir, for successful conducting the 6 days FDP program, sir. And also, I'm grateful for the opportunity to participate this FDP, whatever having the quantum cryptography and its impact cybersecurity in the digital age, sir. Whatever this program is a very highly informative and well structured your design, sir. Whatever the fundamentals also you are making as a sessions into the all days, and also whatever the sessions engaging by the resource person, they giving the very explaining easy manner or simple manner, and also they are giving the some real time real world applications also, and whatever they are giving the some discussions the based on the whatever I'm understanding for the my motivated to me what those help to us explore my research opportunity in this domain, whatever having the quantum, because the next future is next to up to 10 years we are having the quantum cryptography only, and overall this FDP is very excellent, sir. As per my knowledge, this is whatever this perspective. This is for only future cyber security in the digital, sir. I sincere thank to the whatever having the organizers, whatever the conducting such valuable program, sir. Thank you, sir.
Sharda madam.
Yes, sir. Thank you. Thank you, sir. Thank you for your valuable information, sir. If anybody interested to share your views, please share it. Sir,
Okay, madam.
sir.
Good evening, everyone. This is Dr. N. Chandramoli, Program Coordinator. It is my great pleasure to deliver the valedictory message of this AICT sponsored 6-day online faculty development program on quantum cryptography and its impact on cybersecurity in the digital age. Over the last 6 days, we have had enriching sessions on quantum cryptography, post-quantum algorithms, cybersecurity, strategies, and practical applications. The insights shared by our distinguished speakers have provided us with a clear understanding of the opportunities and challenges in the emerging field. I sincerely thank AICT for sponsoring this program, our management for their constant encouragement, and all the eminent resource persons for their valuable contributions. I also express my heartfelt gratitude to our principal, faculty colleagues, press, and organizing committee members for their dedicated efforts in making this FDP a success. Finally, I congratulate all the participants for their enthusiastic involvement and active participation throughout the sessions. I am confident that the knowledge gained here will inspire further research, innovations, and collaborations in the area of cybersecurity and quantum technologies. Let us take these learnings forward to strengthen both academia and industry in this important domain. Thank you all. Thank you for this opportunity.
Thank you, sir. Thank you for your valuable information, sir. Now it's my pleasure to invite our respected principal, sir, Dr. C.H. Srinivas, sir, to address the FDP valedictory session.
Respected General Secretary and Correspondent Dr. G. Srinivas Reddy Garu, Joint Secretary Dr. D. Srinivas Reddy Garu, members Sri Vishwanath Vinod Garu, Sri C.H. Prakash Reddy Garu, coordinator of the today's program, co-coordinator, faculty members, organizing committee members, participants, and eminent speakers. Very good evening to all. At outside, I am very much thankful to the AICT for sanctioning the 1-week online FDP program to Vageshwari College of Engineering in the emerging areas of quantum technologies. I'm also thankful to the eminent speakers for delivering the lectures in spite of their busy schedule, and thanks to all the participants for actively involvement. It's great to see all the sessions with a meaningful and takeaway technologies. As everyone knows that quantum technology is the buzzword, and future is going to be AI-based business models which are going to develop in all the sectors, including manufacturing, banking, telecom, in all sectors, AI plays a major role. Like that we have seen in 2000s, how the computers have been involved in all business modules. AI feature is going to be. In this direction, the quantum technology plays a major role.
and cryptography, cybersecurity. We have been facing the cybersecurity issues for the last 2 weeks in Telangana, some of the other parts of the India also. Cyber attacks have been occurring on education institutions, taking away all the data which is available in the websites, particularly academic institutions, even including JNT. So, my dear faculty members, we have to face and solve the issues and implement for the benefit of the society and teach to the students how to overcome the issues like cyber attacks or how to implement the quantum technologies in the emerging areas. We have to train the students in the classrooms. Obviously, they'll get the benefit in over a period of time. All the lectures have been delivered in a systematically. Participants might have earned knowledge by attending the program. Obviously, the lecture notes will help them for pursuing their PhDs, research works, or implementing some sort of the projects for the final year BTech students or MTech students. I hope that give a meaningful and useful technologies for all the participants. Good luck to all the participants and do well in the future endeavor in your teaching profession. Good luck. Have a nice day. Good night.
Thank you, sir. Yeah, if anybody, if any faculty members or participants want to share, you can share your feedback. So I sincerely thanks to distinguished resource persons who have enlightened us with their knowledge and expertise throughout the sessions, and organizing committee members, technical team members.
Madam.
Sarada madam, Vinod sir వచ్చారు. Vinod sir తో ఇవ్వాలి.
Sir, okay, sir. Now I would like to invite Sri B. Vinod sir, member of Vageshwari College of Engineering, to share few words about this occasion, sir.
Good evening, everyone. I am very happy that the 6-day ACT sponsored faculty development program on quantum crystallography and its impact on cybersecurity in the digital age have been completed successfully. The session will be very useful and thought-provoking for all participants. I appreciate that Department of Computer Sciences and Engineering for organizing FDP with great commitment and teamwork. The program is the program is in line with the vision and mission of Vageshwari College of Engineering, which always strives to provide quality education, promote advanced skills, and prepare both students and faculty for future technologies. I am thankful to ACT for sponsoring this program and the resource persons for their valuable sessions. Also, congratulate all the participants for their active involvement. Hope the participants must have gained knowledge with the FDP, which will help in teaching, research, and building in strengthen future in cybersecurity. Good luck to all. Thank you.
Thank you, sir. Thank you for your valuable message, sir. Now I sincerely thanks to distinguished resource persons who have enlightened us with their knowledge and expertise throughout the sessions. Organizing committee members, technical team members, coordinators, sir, co-coordinators, sir, supporting staff members who hard work behind the screen made this FDP smooth and successful. Finally, I thank management and administration of Vageshwari College of Engineering for providing us with this platform to conduct such a valuable programs. With these words of gratitude, we formally bring this FDP valedictory session to a close. Thank you all. So shall we close the program, sir?
Yes, madam. Thank you, madam.
Thank you, sir.